Let's assume everything's a go. And welcome everyone to the Keshe Plasma Reactor Group for Tuesday, June 6, 2017. And as usual, we're here with a few other people in the Zoom room, which is available to people that would like to discuss their show and tell their various things that they've developed that might have to do with what we call plasma technology. And other people are on the live stream, which I've got to get that set up in my other screen here. And basically, I think we're ready to go for today. So, as is tradition in this genre, we usually call upon Lee Coates to see if he has anything strange and unusual to show for this week's episode. And if not, that's understandable, because he makes so many things. Hello, Lee, is that you?
That's me.
Do you have something you want to show this week, or what's up with your end of things?
I haven't got anything new I built, but I had a crazy idea pop into my head this morning as I woke up.
Okay, that's close enough.
But I probably got to draw a picture of it and show you. And right now I'm trying to get my bamboo drawing pad up and running. I'm downloading some drivers for it. So okay. I'll let someone else go first, and I'm going to see if I can get my drawing device
perfect working. All right, sounds good. Okay, anybody else have anything they would like to bring up or present at this juncture?
Let me.
Ah, Denny, you're always good for something. Better being good for nothing.
Well, I'm working on some things, but this here is what I'm going to show you now. I'm going to share screen.
Is your audio still working, Danny? You're muted right now. Okay, there we go.
Yeah, my audio is working now.
Okay.
So anybody recognize any of this? Understand any of that? Serial dilution? Homeopathic potentization? Quite similar. Serial dilution. This is a 1 to 100 dilution. In other words, I take 10 milliliters out of my CO2 kit and I put it into a liter jar that has already had 10 milliliters taken out of it. So that when I put my 10 in there, it becomes a liter. In this way, I don't have to take the salt out of my CO2 kit. Because by the time I get, I don't even care, down here to the fourth percussion, down here to the fourth bottle, you won't taste any salt. You probably won't taste any salt on the third bottle. And so people like the number 9. And so the farther you take out, you do this serial dilution or the homeopathic potentization, the more potent the liquid plasma becomes, according to serial dilution and homeopathic potentiality. Okay? Now, I put those words up there, so if anybody wanted to look them up, they could. Let me see, I got a couple of YouTubes that people could watch. And so let's just say you went all out and you were just a minute here, I'm having
Now, Denny, you got you mentioned till you reach the 99th bottle. Is that what you mean, or ninth bottle?
Yeah. Well, you can go all the way out to 99. I use these quarts because they're close to a liter, and there's always 10 milliliters left at the top in a quart bottle to become a liter. And quart bottles are just a little bit less than a liter, but that they don't qualify filled all the way up to the brim as the quart. They go up to the neck, and so there's still enough space in a quart bottle to become a liter. And liters are so easy to measure where quarts aren't. So I have 99 liters down here. So you could take this out to the 99th. In other words, you just keep going. You take 10 milliliters out of the ninth bottle and you put it into 999 milliliters into the 10th bottle, and you keep on going. And so that the theory behind potentization is that it becomes more potent as you go farther out. Now, and it's all up to you. There's a certain point where it becomes stronger, and there's all sorts of patterns involved in. I mentioned the word rhythmatic dilutions. In other words, when you succuss or shake the bottle, there's a system where you shake the bottle the same number of times. You shake it the same way. Another, see, this little liter bottle I have down here with a cap, that's when I would shake everything in, and then I'd pour it into the quart jar. So I may want to twist it back and forth and shake it back and forth, so it's like a figure eight. I may want to spin it so it's like a vortex. I may want to spin it one way, and then I may want to spin it the other way. And so that's where, when you're doing the succussion, which is the shaking, when you're trying to do the same amount of shaking the same way, the same time. Now, so that was why this CO2 kit would be called the mother solution, and the rest would be the number of daughters that are out there. So to understand what you're doing is that, let's just take it to the ninth bottle. Okay, if you wanted to start drinking a liter of the ninth bottle solution, so you get yourself your 10th bottle and you put 10 milliliters in it. And so you would have 100 liters drank before you emptied the ninth bottle. Because when you put the 10 milliliters, that ninth bottle becomes a full liter. And so you're taking 10 milliliters every time you drink a liter. You're taking the 10 milliliters out of the ninth bottle. And so once that's empty, you go back to the eighth bottle and you take 10 milliliters out of that. While you put a 90, you put 990 milliliters in the ninth bottle. And so then you go back to drinking the ninth bottle. So when you finally finish the ninth bottle again, 100 drinks, then you go back to the eighth bottle and you take the third 10 milliliters out. And so it's a constant supply when you do something like this, but that's not the important factor. The important factor is, where do you feel the most potent solution is, or the most potent dilution is? You may have to do it by experience, by intuition, by muscle testing. You may do it by pendulum. You may do it by understanding the energies around the bottle. this is all up to people's abilities to understand what it's after. Or you could just do it by rote. Okay, 9's a good number. I'll take it out to the 9th succussion and onto my 9th bottle, and I'll go from there. Or you may think, oh, I got 99 quarts of jars just sitting down there, clean as can be. I could take it all the way out to the 99th succussion or the 99th bottle. So does that help in what I was saying about rhythmatic dilutions last time?
Yeah, that makes sense, Denny, and that's pretty much what I had envisioned the way that it would work. Mm-hmm.
And so all of this is somebody can take and put this in the chat if they want to, but it's on here. When they view it, they can see it. They can go to, because there's a lot of YouTubes that explains this. There's a lot of information about it. There's a system of flower nectar type of homeopathic potentization. There's reasons that people give. Of course, when it comes to this, there are a lot of naysayers as well. And but yes.
One thing I would perhaps take issue with is the initial part there, the contents of the CO2 kit. I know what you mean in terms of the salt will be diluted and so on by probably the 2nd or 3rd succussion, basically. But if I'm just trying to rationalize the idea of using the contents of the CO2 kit rather than, why not just use the pure CO2 GANs and GANs water or CO2 plasma water?
There's another thing about taking it off of the top. I forgot to say you take it off of the top of each bottle because the potentization of it rises to the top.
But what about? But
okay,
normally we don't use the contents of the CO2 kit. We use the CO2 GANs
water,
not all the salt water. That's why we
You wash it out
initially.
You wash it out. Here's a train of thought about both of them. Don't want the salt, you wash it out. You wash the GANs at least 3 to so many times, 3 to 7 times. You get rid of the salt. Then you have seven times that you've washed it. What you do with the water. The other things is the type of salt that you're using. Let's say you're using a type of sea salt and you got all the minerals in there. So you have all the minerals in there. When you make your dilutions and you're making your potentization, there may be a reason why you would want minerals in your
well, that's exactly what I was thinking. If you may not want super potent, certain trace minerals that are in salt water, you may not want them potentized.
You may not want that at all, and so it would be to your advantage then to wash the GANs water and to get the salt out of it, so that you've washed the salt. Oh, there's still going to be, even when you've washed the salt, there's still going to be the essence of the salt in it. But I'm not saying that's another school of thought, because other person would say there's no essence of salt in there. You've got this, and there's no validity to this homeopathic stuff. You just take the 10, you take the the stuff off of the liquid plasma, and when you get down to a certain point, you put more distilled water into it, you shake it up and let it settle. So, but that was one of the frames of thought that somebody wanted to explore. I think it was Vince brought the topic up. I happened to be just coming back to my computer. I had to help Christopher for a moment, and so I wasn't in on the full conversation. But so this
that's a really good description there, Denny, and I love the way you put it visually, so that it's not just a talking thing. You can actually see how it's done from bottle to bottle, and that's basically how to do it.
So people can go and research homeopathic potentization. Sometimes it's spelled with a Z in the zation, and sometimes it's spelled with an S, and they can read about it. Same thing with the serial dilution, which is different than just common dilution. And there's math that goes along with this and how you can figure it out. And these two YouTubes that I have down here describe part of it. And the reason I should put them up there is so somebody viewing this can take a look at those two, whether they're on live stream or whether they're on YouTube when they're watching this. So that's it. That's really all I have. If anybody had any questions,
it'd be great to get Mr. Keshe's comment on this concept, because he's published a paper on homeopathic, sort of the way the Keshe Foundation approaches the homeopathic, which is similar in a way.
Did you read that? I haven't had a chance to get a hold of that.
I don't think I have that one. I tried to download it one time. I had some issues, I think.
There's another thing that I haven't written down here, is that this is a 1 to 100 ratio. In other words, I've got 10 milliliters to a liter, which is 1,000 milliliters. So you just divide, and it's 1 to 100. You don't always need to have a liter bottle. You could have it, you could take and use drops, 1 drop to 9 drops. You can use 1 liter or 10 liters, 10 milliliters to 100 milliliters if you have a container that's that size.
Or 10 to
have to be that size. Remember, succussion is important. You have to shake it. You need to shake the solution. You need to get the flow going in your bottle. So there's YouTubes that go about that. And this 10 to 100, of course, then would be a 1 to 10 dilution. It can be written like this: 1 to 10, 1 over 10. So that's one of the things I didn't write down, but now you can see it. The example that I've used here, that I've done in the drawing, and I've used the quart jars. Of course, that's a 1 to 100. So that's that. Anybody have any questions? If there's no questions, anybody have anything in the chat? If there's no questions.
There was a question in the chat about how long does the plasma water, how long will it be in the charged state as plasma water?
You're starting out with the plasma water, taking 10 milliliters, and you're potent. Using the potentization, you make it more potent. In other words, this first 10 milliliters you're taking out, by the time it gets down here, is more potent. It'll be stronger, more effective for the purposes that you want to use. That's why you would use this type of system. So when you get to this point and you're going into your 10th bottle, and here I'm just going to use the quart bottle, you filled it up to 990 milliliters, and you dropped the 10th out of here. Now this becomes a liter. I don't care how you do that. You can take one little sip an hour. This is all up to you. Whatever you do, it's all up to you. It's what you like. Now, again, the tests that they were doing in Japan and were not the homeopathic system. They were using a different dilution. I think they were using out of the top of they were taking their GANS water, their liquid plasma. They were taking the CO2 kit, washed the GANS, got the salt out of it, and then they had a kit with some GANS in it, and they took the certain portion of the water out and put it in the container. No GANS, just the liquid plasma, or let's just say the water that came off of the washed GANS. And so now the liquid plasma is what they use. They took just that, and then when they ran out of it, they had filled this back up and had shook it and used more of it. I think that's the way they did their test. They didn't do the homeopathic system. The question was, what's the homeopathic dilutions look like? And so I thought I would show you. And
that would be a good way to phrase a question to Mr. Keshe. Is there value in doing it through this multiple succussion homeopathic method as opposed to just a simple dilution method, let's say, where you put a few drops in maybe several liters of distilled water. You put a few drops of the plasma water, and that's enough to activate it, let's say.
Serial dilution is used in modern chemistry as well, not just homeopathic, but it's used in modern chemistry as well. It's a type of dilution, which is very similar to the homeopathic solution. When you get into the biodynamic gardening that Steiner used, there was more of a series of how you did the succussion, what was important. There's even music you play, there's even the light you put on it, there's a whole frame of thought and ideas about the succussion and what to do. And that's the field that takes too long to go into tonight. And if anybody wanted to do the research, it's there to be had. Just by looking up homeopathic potentization, you could probably go to and wiki. What is that? What is that? Where you go and they give you, you go to Google and you type in the things that you want, and it comes up with the wiki definition. You do that quite a bit, Mr. Keshe.
Yeah, well, I just usually look it up in Google, and it'll give me the wiki It's usually at the top of the hit list.
Yeah. If somebody wanted to do that, they could do that. Anyhow, I pretty much have gone through it. There's styles and preference.
I was going to suggest that probably with the scientific method, which would be very similar to this, probably without so much shaking, maybe stirring or something. But it's convenient. It's convenient because it's 10 or 100 or whatever ratio you have, and it's easy for them to figure out basically how many molecules they have left after a certain number of dilutions and so on, of their exact ratios.
They do that because some things are harmful to the body, so they take them out to the smallest dilution they can get, so that that's no longer harmful. There's machines that do the shaking. There's titration systems, that the little pipettes that are all calibrated to where it picks up just the exact amount you need and drops it off into the containers. They pick up microliters, and so I guess I guess I don't know what a microliter is. I think it's just a milliliter. So anyhow,
a microliter would be a thousandth of a milliliter, I believe.
Okay, pretty small.
Pretty small, yeah.
and so this is big. This is the information is there. The understanding is easy to understand. When you watch a YouTube and they show the math, it's easy to understand. Let me step out of here, and I don't need to clear this. I'm just going to step out and stop sharing. And if we have the time, let's pull up a Google homeopathic potentization for me, Rick.
Oh, okay.
And just so that people have an idea what the definition might be. This has been way longer than I thought I was going to present, but this will give.
What do you want specifically? Homeopathic dilution or?
No, homeopathic potentization.
Potentization, okay.
Potentization. And you can also put an S where the Z is. Did you get anything?
There's potentization in Rational Wiki, whatever that is.
You got homeopathic potentization?
I never heard of Rational Wiki before, but that's what they're
put the S
talking
in
about.
Instead of the.
Let's have a look. Let's have a look at it. Pull that down. Get that over. Again, make things a bit bigger.
You just wrote potentization. You didn't put homeopathic?
No, I put homeopathic potentization, but this is what came up under the wiki part.
Yeah. Can you make that a little bit bigger, print?
Can you see that now?
Yeah. Potentization, also known as succussion, is the term homeopaths use to describe the series of stepwise dilutions used in preparing their medication. I was showing you the ratios there, and I wrote it down. That was 1 to 100. That was the one that's the one that's being demonstrated. Here they were whacking the bottle. Does it say in here to do all this stuff? They used to have people at lighthouses do the percussions of things because they had nothing to do while they were waiting in the lighthouses. So anyhow,
they don't seem too positive here on I think Rational Wiki is for skeptics. I think it's for skeptics because they're kind of putting it down. They're talking about a strong lack of evidence and that it makes any difference and so on and so forth. So they have the scale here.
A 1 times x is 1 to 10. A 2 times x is... So, yeah, you can get all that stuff. You can read about it, or you can watch it on the YouTube. They'll show you on YouTube. So you've got plenty of YouTubes out here on this stuff. Well, I didn't need to spend too much time on it. I was just letting people know they can go to...
a good spanking. Make sure they will remember. So yeah, they're a bit cynical.
This was not the wiki that I went to, nor the search that I.
Yeah, sorry, I got diverted into that one. I got sucked in.
Yeah, you're a bad example.
Yeah.
So anyhow, I'm done. Anybody wants to do it?
Yeah, if somebody, that's right. If they want to get into it, they can look into it deeper.
Okay, well, I'm gonna mute myself. Goodbye.
Thank you, Denny. What happened to my video here? Seems to be disappearing. Okay, I'm gonna have to stop my video, I think, and maybe do... Come on. Okay, maybe if I stop the screen share, everything will come back normal. Ah, there we go. Relatively normal, if you consider me normal. Good luck. All right. Very good, Denny. Thank you very much. And let's move on to our next featured guest. Maybe we can go back to...
Let's see if my tablet works.
Yeah, let's go see if Lee's tablet works. That would be good.
I gotta find out how to get a white screen up here.
Do you know the share screen whiteboard? Is that what you mean, or on your tablet?
No, the share screen whiteboard.
Should be just share screen and then select whiteboard up at the top somewhere.
There we go. Okay. What I was thinking about the last few days or last night was I got to learn how to use my tablet again. I haven't used it in a long time. Oops, that's not erasing. Okay. Now I've got to find a pen. Draw. Okay, what I was thinking about was how else can we arrange our coils, or what other shapes can we put our coils in to make some kind of interesting plasma device. So the idea that hit me this morning is, what if we run them up and down in like a cylinder. So if we had a say a piece of 2-inch pipe or something. Oh, I need practice. Let's get a better pipe than that. And then we put, say, 9 coils around it, all going up and down. 1, 2, 3, 4, 5, 6, 7, 8. Anyway, we'll put another one in the background, so we got 9. So these are just a standard copper coil going up and down. So they're like, I might do better with my mouse. Okay, so we got there'll be the double coils with the gravitational inside and the magnetical outside. And so think of what we could do is like unwrap this from around the tube, and we'd have these 9 coils sitting there side by side. And I'm just going to go dot, 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 and over to the 9th one. So we'd have a gravitational wire going in here with a flow going in. And up top, the gravitational would go into the other gravitational. So we got the flow going down now. And then we're going up, we're going up. And then we're going down. And then what's on the 9th one? Let's say we're end up going up again. So, and then from this one, you'd have your grav out on top, but it would connect to the mag in. So the mag is now going down. Let's change the color here. So we've connected now to the green outside one. The flow is going down, and so it's going the opposite direction. So it's going up. So now we got this oscillation going up and down, up and down, up and down. And then we got our mag out, flow going out. So we got this flow going up and down, up and down, up and down in a circle here. And now the question is, what can we do with that flow? And I was thinking, why don't we put some coils around this thing? Another set of mag grav coils around it. And then how many, I don't know. Maybe we put 3 around it. Maybe we put 9 around it. Maybe we, however many. So let's say we take the mag out from the inside coil and we go to the grav in here, and then we connect them, grav to grav out to grav in, grav out to grav in, grav out, all the way up to the top. Then we come back down, mag out to mag in, mag out to mag in, back down to the bottom. So we end up with a mag out at the bottom. And so we got a grav in and a G in and a G in and a mag out. So I was wondering if this would be like an oscillator, whether we can, it would somehow, because we got these inside fields going up and down and then they're being picked up by the rings around the outside, whether we can create some kind of an oscillator. And of course, inside the pipe here, you'd have some Gans balls, probably a stack of Gans balls. maybe that's, the strengths of the GANS balls would go from strong to weak, so you get some flow going up the middle as well. So
I like the idea of the sort of intersecting fields concept. You have two totally different orientations for the coils, and I think that's important to get a cross, would you call it a cross, not interference, but cross interaction with the fields.
And yeah, that's sort of what I'm thinking about. Is there's got to be something with an arrangement like this. I'm not sure just what. Another thing, like Dr. Keshe was, or Mr. Keshe was saying, what if we have some tubes with plasma flow in it? So what if we? Oops, lost my pen. What if we just end up with some plastic tubes wrapping around this thing through the center instead of GANS balls? I can't draw tubes very good or circles, but and then put a little 1/4-inch aquarium pump on it and pump the GANS around this whole thing too. I don't know. Might be another thing to get something flowing, but anyway, anybody else think this thing has some possibilities?
Well, I guess you get me to respond. On the some of these straight coils, especially the one on the end, the 9th one, almost acts like a capacitor battery by the way it's connected to itself. But so that could possibly be one thing that you don't have to worry about the capacity and the battery side of it. Okay, so when you're going to flow through the tubes, if you make the tubes separate and have a little pump on each tube, there's a variety of pumps. You can even you make them so that they would have different GANs in each tube, and you can control the speed of the GANs in the tubes, and you can control. Well, I guess you can just say control the speeds of it. You could do similar with your in between your mag-grav coils that you're putting around there. You can space a tube that goes around there as well. So I'm just looking at form. I need somebody that understands the flow and looks at the flow, looks at these things as how the plasma fields flow and move. It would take me a while to figure that out.
Well, one thing we should keep in mind is what is the intention of this, Lee? Like EC mentions in the live stream chat, what do you plan to use this design for? And he says,
well, I'm wondering if this is the oscillator we're looking for the generator.
Okay. I was looking at the core of the spaceship engine, basically, but it could be the same thing.
I'm trying to get something that gives an oscillation. I'm thinking this up down would be may give an oscillation.
Yes,
and how do you pick that oscillation up to use it somewhere else?
Well,
is this like an electric LC circuit?
Right.
Plasmatically. I don't. I'm not.
Well, in a way, it's sort of you're looking at some kind of friction of fields, perhaps, which EC mentions here. If the coil windings are alternately clockwise and counterclockwise, maybe friction of fields could generate heat inside to make hot water without any fossil or renewable energy source. So that's an idea, and perhaps, you know, you mentioned a circulating system with a pump and fluids. What if those fluids?
That's what if the idea?
What if the fluids, whatever the fluids happen to be, GANs or some other fluids, maybe ferrofluids or something? What if they were sort of the look at it as a three-layer system. You've got your core, where you've drawn the tubes. You've got your outer skin, sort of, with the coils around, you know, that contain the core, protect it in a way. And then you have this sort of nervous system of tubes that flows or interacts or exists in between those two fields, let's say. In between those two entities, the core and the outer coils. So maybe that system of tubes could pick up on the friction of fields that are happening due to this configuration. The you know, you definitely have a not conflicting fields, but you know, at just the right angles, then the fields will be interacting in a certain way that's different than when they're all lined up together in a coil or double coil. So perhaps that pump could end up pumping to take away the heat of the system and using it for some useful purpose. Or perhaps it will end up cooling instead of heating, and you've got a built-in air conditioning system instead.
Your center pipe, the one that acts like a form that holds everything together.
Yep.
You might as well make that a double one.
What do you mean?
Put a say if your pipe was a copper pipe that was a inch pipe, you'd put a half-inch pipe and spacers there so it could flow, and that's nano coated, and you may want to put power to that as well.
What if we just run a water pipe, put this around a water pipe, and all this back and forth plasma agitates the water?
Yeah, maybe it'll even make the water flow, because water does flow from what do they call it? Magnetodynamic. You know, you can take salt water and cause it to flow through a coil. You know, a tube with a coil around it. Yeah, that's an idea, actually. It might be a self-sustaining water heater or cooler.
Well, you also have the health benefits. When you flow water, if the water in the pipe is the flow, it runs the current. It runs past the fields in the GANs. It will pick up whatever you have in that liquid plasma. It will pick up the fields as well. Then if you drink that water, you will be taking on the fields of the GANs. In fact, you would put nutrients, if you want, in the tubes that you would have. And so when you run your water past that unit, you don't put any electricity to the unit. The fields are being naturally given off. What we did, I don't know how many years ago, I guess it was back in the 80s, so that's quite a few years ago. we had what we call the homeopathic magnetic aligning water revitalizer unit, where we ran the water past nutrients and 2 sets of magnets. And I got all sorts of testimonials of how it helped people's health. And so this would be a very similar technique of picking up, but here we weren't using liquid plasma at the time. We were using other technologies along with radionics, but we were putting fields in the nutrients of the water that then ran the water past the little container that had the nutrients in.
Be like a direct exposure to those nutrients, though, right? Or...
No. The water didn't touch the nutrients at all.
Oh, I see.
It was
what kind of container? Like a stainless or some other?
There was 2 we had. We had a metal, and we also had a plastic.
Mm-hmm.
We had a dairy farmer that did a lot of tests on the mineral that he had. He computerized what he had in his food. He knew exactly what was going into the cow's food. He knew exactly what was going out on the field in the field mineral blocks. He took all the mineral blocks out of the field because the cattle weren't eating the mineral blocks. He then took all the minerals out of the food, and the cattle sustained themselves on just the fields that the water picked up. It activated the minerals that were naturally in the water so when the cattle drank it.
Interesting.
And so I'm just saying that this would act, if you were running water past it, you would be naturally picking up the nutrients that you had either in the tubes or on the coils themselves. Because if you put something on the coils, they're gonna have the field flow, and when the water runs past it, you're going to have the vitalization of the water as it picks up the nutrients that this little unit you had.
Or it might have a decontamination aspect to it. Instead of nutrients, it might be taking out contaminating things as well. Being if
you studied it out, you could probably figure if I use this, it will do this to my water. If I with a little bit of time and effort and experimentation, you could take a system like that, and even your own maggrav system, if you put it around the pipes itself, and just ran a slight current through it, so small, or even none at all, and used a unit. In fact, if you took liquid plasma, a couple of bottles of liquid plasma, and put it on each side of the pipe, you would pick up fields. I don't know if people are doing that right now, but there's probably some people who are already experimenting with that. Anyhow, that's all I got to say.
All right, anyone else with some comment on this design? Going once, going twice.
That might end up for yes, it looks good for me.
Okay.
I love all that crazy stuff. More coils and wires.
Yeah, well, it reminded me of some of your creations there, Mark, with the coil, the vertical coils, and so on. Yeah.
So when you see some of my things, I got a couple of things. It's just funny how Denny or Lee and I run along the same lines, because when you see what I've was working on this week. It's fun or funny.
Can we see that thing now?
Sure. Once Lee's done or Denny's done, and
well, Lee, are you
done
with that?
Done.
Well,
well, the interesting part of this is that Lee mentioned that. Let me start my video so we have something to look at here.
Yeah, thanks for your comments, guys.
Just a second here. Pin it and stuff here.
What's so nice about Lee's system is that he has everything to make it. The coils that go up and down are basically mag-grav coils that aren't connected end to end, but are standing straight up and down. So he has all of that probably right at hand where he could test it out.
Well, what I was going to mention that I thought was really cool was the fact that he woke up in the morning and had this idea that sort of popped into his brain. I thought that was an interesting aspect. Can you say something else about that, Lee? What does this happen to you a lot? I mean, many people they might ponder something at night and you go to sleep and then you wake up in the morning and the answer is there, that kind of thing. Is that sort of what happened, or have you already been working on this problem?
No, I think when I went to bed last night, I was sort of thinking, how else can we rearrange coils to do some useful work? Because most of the designs we see, they're all going in circles. And, I got a mag-grav sitting beside my bed on the night table, and I just wondered maybe the idea came from the plasma or something. And I woke up, 20 minutes early this morning, and this idea's in my head, and I'm saying, how did that get there? And I got thinking about it some more, and then I said, I'm going to run it by the boys tonight and see if they can add anything to it.
Oh, that's great, because it could very well be that we receive some of this information from our subconscious or from the universe, or say whatever you like,
our higher self.
Yeah, which is often when our physicality is so exhausted it finally falls asleep, and that's where all the fun stuff happens.
Have you had a chance to figure out the oscillation factor? Maybe you would only need 3 coils, the upright coils.
That's going to be the tricky part, because there's no precedence to this. We got no meters to measure anything. You could make one of these and it didn't seem to do anything yet. It may be just because you're not balanced out or lined up or whatever.
But you have a secret weapon now, Lee. You can feel the fields, right? Well, think about it. You just kind of, I mean, you've already got design sort of ethics and designs. You know how to make design. You create things all the time. You have various manufacturing procedures that and so on and so forth. So you already know the aesthetics of it, and now you get to play a little bit. Should it be 3 coils, 4 coils, 5 coils, 6 coils, 7 feels right. 7, let's go with 7. Feel it somehow. Maybe put 2 to 3 together. 4 feels better, but it's not balanced, or however you like to interpret it as you go along. But you do have a secret weapon now that you claim you didn't have before, and now you're allowing that into your life. So it's another tool, another way to approach the problem, not problem, but the design process, you might say.
Yeah.
So
it's
actually
really a question of
2 secret weapons now. 2 secret weapons. You got you feel the fields, and you're getting information in your dreams. So if you request what you want at night, after you've been feeling the fields, and you know, should it be 6 or 7? Well, I'll sleep on it, and the answer will come to me. And you wake up in the morning, all right, it's 7 for sure, you know, or whatever, you know, just give them that.
I better sleep on it again tonight, and then see if they tell me I should spend some time on this.
Yeah.
So
well,
what you're hunting for is an off-grid system or something to make your car get better performance, and you may well end up with
I want to power my house. That's what I want.
Yeah, I mean, you're wanting that off-grid system. That's what you're looking for.
so he's working on basically the heart of the system, the beat, the pulse, the oscillation, yeah, you know, and there's a movie called Buckaroo Banzai and Adventures Across the 8th Dimension, I think it is, or something. And they have the overthruster, this little device that's the key to make the spaceship work properly, and so on. So it's interesting. It seems like that in a way. This it was an overthruster oscillator was this device, and it seems like that oscillation is the key. That's the key in a way. So yeah. Okay, so what else about that? Anybody have more to say on it? All right, well, let's go along to Mark's, what Mark has to remark about today. You know, he says something remarkable. Are you ready to go, Mark? Or, oh yeah, there we go. What was that?
I don't know. Somebody was getting their motor ready.
I think Space Dream. I think I better mute you. I think you probably don't know you're unmuted.
No,
sorry, he says. Okay. It was good.
Well, I guess it was a good way to start it up because
it was perfect. Yeah.
So today, it's just funny that Denny we're all talking about the spirals inside a tube and stuff. So I'm working on my capacitors. But I've been working on a lot of stuff. This was a busy week for me. I'm telling you. If I told you all the stuff that happened this week, it'd just flip you out. But I don't know where you want to start. I got a whole bunch of start points that we could start at. But if you want to look just up in the very upper corner, I got that ground tube that we talked about. I got it finally. I got it installed.
Oh, you do? That's the copper pipe grounding tube that, for those that didn't catch last week's episode, right? Correct?
Yes. Correct.
And you've pounded this into the dirt, into your soil or whatever that's outside the house? Is that the procedure? Tell us about it.
Yeah. Well, maybe I should, let me see if I can. You know, I should have did this first. No, I got it. I'm not. I should. You know, let me just try this once. I have pictures of it. So if you give me 1/2 a second, let me just pick up the pictures.
Oh, great. Thank you. We love pictures here.
You know what? Darn it. I didn't download those on this screen here. They're still on my phone. I don't know how to get to my phone from here. So I guess we'll just move on from that. I'll try. Could
you hold your phone up in front of your video?
Well, you know what? Whoever had the motor on, I could get the pictures downloaded in like 5 minutes to make the to kind of give you a little, kind of. If you give me 5 minutes, it'll be worth the 5 minutes of me setting it up.
Yeah, that'd be great. Thank you.
Okay.
That's perfect,
I
Mark.
just let me. It'll be quick. I'll be very quick about it, so somebody else can go. Whoever had that motor, that was a sign.
Yeah, maybe we'll leave your picture up here if you don't mind, and
sure, go right ahead. I'm just going to mute
bounce off
myself because you'll hear me all ruffling and shuffling.
Perfect. Thank you.
Rick, can I ask you a question?
Yes, Zane, go ahead.
Whenever a DC, like a, I'm sorry.
There's microphone noise. It's okay now. Go ahead.
Okay. Whenever there's a DC, like a car battery, 12 volt, right? Okay. Whenever it becomes plasmatic, or if we add GANs to it and to the cells, and then hook a few capacitors to it, maybe make a battery pack, and let it nano coat itself. Is that a good thing, or? I don't know. I'm not.
What do you hope to get out of it? What's it going to do? Is you want a plasma battery of some sort? Is that the idea?
Yeah,
or do you want an actual energy source that'll give you electrons to light lights and stuff, or is this
something like that? You know, me and a friend were discussing today. See, we got a 3D printer, and I need some assistance on getting it operative. But
on a what again?
A 3D printer.
3D printer. And, okay. Yeah,
we're having a little bit of trouble getting it going, but you know, we were talking about making some graphene filament and making like hoses that are, you know, graphene tubes, and then the inside has like a swirl to it where you can run water through it, and you know, that would create power, you know. And
how would it create power?
Due to the water running over the graphene. But it's just ideas that we're, you know, going through right now, and I've made a few things, and I would like to show y'all, but I'm in the process of moving and trying to get organized, so it's kind of emotionally draining. But we're doing this, you know.
You're moving to a new place?
Yeah, I got there today, but I don't know. We'll see what happens. Tomorrow's a new day, you know. But
are you gonna have a bit of a lab space to work with?
Well, that's what we're working on trying to find.
Okay.
You know, where we're at, it's good for us to meet and get everything, you know, like organized and a good idea of the goal that's ahead of us. But maybe it would, well, it would be easier if we had a little help. But you know, it's just, I don't know, somebody to call or talk to whenever we run into a situation or a problem that, you know, I don't know.
Well, that's what this group is for, as far as, you know, definitely that we can work through things. Just about anything can be a topic of interest here. So keep that in mind and save up your questions and formulate them and have some data to work off of and some pictures or some other video. You know the drill. It's the more stuff you have that for eye candy for us.
Well, you know, I do have some pictures I can show y'all real quick. You know, just something.
We like pictures.
Yeah, something just to check out. I know. This is.
Go ahead.
This is just something that I was working on, thinking about the pulse. You know, and if the batteries became completely plasmatic, okay, and I had like these rings. I took a wire and I put it in a circle and then looped around it. And with those loops, with it running, it would create. It's like a pulse sort of. And I figured if I stacked the small battery on top of the big battery, with the way that the other cord is, and then tied them together like in such a way that it would just feed itself, and it would be like an oscillator. It's funny that we've been talking about this, but
pretty wild.
I love y'all, man. Y'all are great. Y'all are just great.
Pretty wild. That bottom coil there, the one with you got like a series of wires in a loop, and then you've got the wires wrapped around those wires. It looks very much like the toroidal coils that they have in the where they're trying to make fusion
yes, sir. Yes,
reactors.
Sir.
Well, I think it's the tokamak. It looks that way.
Hey, and you know what? The lights that I had on top of it, they look like a globe. They look like a hologram. You know how it's like a 3D version of the light. It's amazing. It's just incredible.
Which light is that? You mean the LED or?
Yes, the LEDs that are hooked up. You see how it's spread out like that?
Yeah.
Well, it's like that whole thing right in front of you. It's just amazing. It's like the air is so ionized or something. You know, it's just amazing. Yeah.
Well, and what if you done something to these batteries? Have you put?
Yeah. The big battery and the cells, I popped it off. Okay, it was a little low on fluid or on water, so I added CH3 to the two outer ends, and then copper and CO2 and then zinc, and but they were all dried, and I put them into the cell, and then I have some real badass. Oh, excuse me. I have some real nice lead GaNs that I've worked on for a good while, and I shook that bottle up, and I topped off the battery with that liquid plasma and the little particles. You know, the good part of the GaNs, the liquid plasma, and I topped the battery off and then popped the caps back on, and man, it came alive, really. I mean, the wires on top of it started moving. You know, it's like they were communicating with each other, looking at me like, "What are you doing? Come on, get busy." You know, so we're having fun now.
Okay. It didn't do any weird bubbling or anything when you added the GaNs, to the acid of the battery?
Nope.
Okay, well, keep on experimenting with it. Who knows? There was a lady last year who had the everlasting battery.
I remember that.
In a field in France.
In her pasture?
France.
Yeah. Hey, can I show y'all something? Can I show y'all something real quick? Cool. See, I'm over at this chick's house, and I hooked up my unit to the back of her house, and I have these light things. Here, let me turn on my video. Hello, hey, what's up?
Okay,
all right.
The pin and spotlight. Here we go.
But I have my unit outside, and in the outlet part, okay, I have these 300-watt lamps that I used to use for my transformation optics whenever I was messing with the graphene, you know, but I don't have the bulb in there, and I figured with that reactor, that ball on top of, the ball on top here, it would feed all back into that. Well, I have 3 of these hooked up, and they're all in like a star formation on the back porch. It's been raining, so, and I come out here to smoke a cigarette because she's got kids, and I want to be respectful, you know. But she's great. She's really great. She's a good mom. Well, anyways, I was looking up at the sky, and the lightning struck, and it went sideways. It was horizontal rather than parallel. And it was like a red color. It was amazing. Just amazing. It was so beautiful. Oh, well, thank you.
Okay, Zane, thank you. It's a nice picture you have there, too.
Thank you. I took that last year. I think it was last year. It might have been the year before last. Man, this has been one busy week. I swear I've accomplished a whole month's worth of work in a week.
Right on.
Yeah, awesome. Thank you.
Okay. Mark, are you ready to go yet? Do you need a few more minutes?
No, we're good. It's just funny how he just mentioned how Zane just put in a month's worth of work in a week. It just felt like that did for me too. I mean, just like this last week, there was just so much I did, but you know, it's just funny. It's just now, you know, people are commenting on it. So anyway, here, let me try to share my screen. Did it work?
I don't think so yet. I mean, I'm getting your, okay, there we go, it's starting now. Yep.
So you see the little, the in-ground tube?
Okay, so yeah, we see the copper tube in the middle, which is your, was it 5-foot copper tube, right?
Yep, 5-foot copper tube. And then I took a 40-foot piece of 14 gauge wire, straight wire. And what I did was 20 feet of it, I made a coil. That's what I cut my finger on, is that coil that you're looking at there. So the 20 feet of that, that's a 20-foot coil coiled up there. And then the other 20-foot is just a straight piece of nano-coated wire. It was all nano-coated together. And then what I did was I wanted it insulated to coming out of the pipe, and because I didn't want, I wanted the pipe and the nano-coating separate. But as you can see, the cap, I don't know, can you see my mouse or my pointer here on the cap? I thought, well, if I put that nano-coated cap on this, I don't want no nano-coating on the outside here. So I scrapped that idea. So I'll move on here a little bit. Here's another one. So what I did was, then I started thinking about it, because somebody said, well, what if you needed to take a reading off of the outside of the outside of the pipe here? And if it's in the ground, I'm going like, well, man, I don't want to go outside all the time, because this part was all insulated here, and this part here is going to go inside up here, and and then I'm going to cap it. I'm putting dry GANs inside. So I thought, well, I'm not going outside every day to take a reading off the pipe and then come inside and take the reading here. So what I did was I took another 20 feet of wire. Well, it's 16 and 10. It was 26 feet. I had 26 feet of this raw, non-nano coated wire, and I just kind of coiled it around the 5-foot pipe there, all the way down to the bottom.
So that's your matter level connection, you might say.
Yes, that's what I thought. That's my thinking on it. So I wanted, in case of, I wanted to have a reading. I wanted, what good is a reading that, from just up here? It's like a thermometer, more or less. I look at it. I wanted to at least be able to have a true reading all the way through the whole thing. So that's why I put the coiled wire from the bottom all the way to the top.
That's great. Nice idea.
My thinking there anyway. So then, I don't know, maybe I'm hoping I have a picture of it, because I changed the idea. I can come back to those. I didn't take a picture of it. But oops. On here, this cap here, I took it off and I replaced it with a non-nano coated cap, because then I didn't have to insulate it, because this insulated tube goes down through. I drilled a hole in the cap and put it all through it instead with the non-nano coated cap. That way, this tube is insulated and it keeps all the nano part on the inside of this tubing here. I thought I took a picture.
That makes sense. It's all separate system there. Yep.
Yeah. So then what I did.
Is that wire all one piece with the coil and the wire inside the tube all the way through, or did you connect them at some point?
Oh no, that was 40 feet of wire, and then.
Right on. Yep.
I didn't want. I thought about putting an arming connection. Then I thought, well, and then I tried. This. I thought, well, because this had this was coated wire here. Which you buy, and then we strip the coating off of it because we want it raw. And then I thought, well, maybe you could do it that way, and just leave it like that. But it was. So then I tried to put tubing back. I wanted it insulated because see right here, I can. This is the end I'm going to use. This is the part that's inside the house. This, this goes through the ground. And then I thought, well, if this is going to be insulated, then I did the same thing to this one too. I put all this through the tubing too. So I'll show you that in a minute.
That's probably a good idea, so you won't get outside interference with it touching metal objects and so on, which could change the readings quite a bit.
That's what I thought. So I snugged that right up to this one here, and it's another tube just like that, and it goes right up to here, and then it goes in through the trench and into the house. So this is the system that it's going on here. This is the stacker system that I'm gonna push it all through. Or this part is going to be the negative part that's going to be connected to the middle. And I can talk about that in a minute, but I just wanted to, I'll finish that, let's see, so you can see what it looks like from the outside. So what I did here was, I tried to figure out what it would look like in the hole. Because all that digging to me was a lot of digging. So I thought I have 5 feet is 60 inches. So with 60 inches, all I had to dig was a trench 50 inches, which cut off 10 whole inches. I thought, well, that's a good idea. And then to make it a square, what I squared it up was, if you just took 33 1/3 inches on the rise to the top of the, this would be my earth plane here, to the bottom of the hole, it was just easier for me to dig. Instead of trying to dig all this here out, I said, I ain't doing all that. So I cut my digging in half. I might be cheating a little bit, but hey, to try to dig it all the way down, because this was just crazy when I first started to dig it, because I thought, this isn't going to be too bad.
I think the Egyptians would be proud of you.
You think so?
Yeah, it looks very Egyptian with all the angles, and it's, Okay, very good.
So here we go. So I get out there and I'm starting digging away.
Neighbors are wondering what the heck is he up to now.
That's great.
Yes, they did. I had a few of them kind of pop their head out and say, and I just said, well, I'm just, all my neighbors kind of, my one who sees this, he knows that I should have a tin hat on anyway, so it doesn't matter. He's been in the lab. He helped me. He's an electrician, in-home electrician, and I had him. He can't figure it out, and he says, I have a hard enough time keeping track of what I got to think about, let alone you asking me questions about things that are not right. I said, don't worry, blah, blah, blah. So when he sees me do this, he just shakes and waves, and I wave and he waves, and we move on. So this is, you can see here that I kept everything separate.
Mm-hmm.
And then I just I made sure the hole was 33 inches deep.
Mm-hmm.
and the angle was I didn't. If you did the map down and up, and you've seen how I kind of laid out the thing. The angle on the map is kind of right, I guess.
Yeah. Okay.
So.
Selfie.
I'm so happy that I'm done.
Yeah. I bet the neighbors are too.
Yes.
Okay, so you backfilled it.
Backfilled it there.
Now, did you add any moisture to it when you backfilled it, or anything else that might have be different? There's just put the dirt back in, basically.
No. I was tired, and it was getting late, and the sun was going down. I was lucky enough to get all this done.
Yeah, man.
So yeah, I just backfilled it. I jumped and pounded and jumped on it.
Okay. Yeah.
So then you see the two of them are coming out. And then what I did with these two, I made another trench from the here to the house. And now you can see everything's buried. And there's the in point into the house right there. My neighbors won't know anything now. And maybe the meter reader might mess up the meter reader, because that's the line that goes from the meter. Whether it's positive or not, I don't know, but it's just, I don't know, it's so low frequency, and that's why I had these two insulated. And this was I had a water pipe here, a window here, wire here, and I'm not calling the city to come and move this. So good luck to us all. Maybe we'll all get a beautiful reading.
Right. Looks really pro. Yeah, looks great.
So that's what you see that was in the basement in the corner there. So then I don't know, how do you stop sharing now? Let's see.
I do it from this end by sharing screen.
Stop sharing.
And let me go back to turning on my. Okay, we can go back to your video.
Okay, so I can get up now. So now you know that's what you're looking at from outside to here, from inside. Let me just get my little change here. So basically, I don't know, last week the only reason why I did all this was because I'm just going to try an earth ground with a positive lead from my power supply, which, I could use a battery, but this already has a fuse in it, and I'm only going to get 1.2, 1.5, because I'm going to make GANs with it now. So I wanted to try to get I don't even know if it's going to work. All that effort, might not even work. Got to try though. So this is the stacker unit that I want to try to put it through. So to make the GANs, to see if this all works, because this is all just kind of a hypothesis for me anyway. So what I'm going to do is, I may, there's a lot more to that, but we could talk about that in a minute. But it's just funny because I was working on these capacitors right here. These are what like Lee was saying. I had a couple of different versions of these, and I finally narrowed it down when it comes to pipes and GANs and wires and tubes. And I tried to put all of the thoughts together because I wanted to make a sort of capacitor. And I had some other ones before that I didn't. They were nice. They held a lot of power, but they just weren't the right design and everything. So these are a little bit more intricate design that I kind of moved closer towards. And I got a little like a mock-up version of it if you want to look at it. Because it's hard to explain if I just
if you can walk us through it, it'd be great.
Yeah, let's move it up here a little bit here. Okay. How does it look?
Yeah, that's great. We can see it really good there, Mark.
Okay, so I made a couple of different ones before, but this was my final version of it. Okay, looks good. So what you're looking at here and what these are here is this is a 10 gauge. Is it 10? 12 gauge. Yes, 12 gauge. This red wire is a 12 gauge wire coat, sleeve, so that's my inner core that's already insulated. Then I took and made a let's see. Well, it's all going to come out, but let's just slide this off the outer part first. So then what I did was this part here is your core, is my core. I don't know if you can you see that?
Yes, it's a little blurry. No, it's pretty good there. Pretty good. Thank you.
Better? Maybe if I just lay it down.
We can see it pretty clear. Yep, nice.
So anyway, there's a core, there's a spiral core on the inside that's gapped, and then I put a stranded wire just to pick up more copper on the inside. And then what I did, each layer is each one of these insulated cores I use nano-coated plastic. And what I do is I heat the sheeted plastic in the caustic solution. So I dip this in caustic. It's about well, I shouldn't, we don't talk about how we nanocoat stuff, but anyway, that's how I change the complexity of the plastic, is by heating it with caustic at a very high temperature, and it just changes the, it definitely changes the complexity of the plastic. What it really does, well, I think it allows gaps in the plastic for things to move through it. It organizes probably the plastic, is what I'm thinking. Just like it does, it brings order to everything else we do. Why wouldn't it bring order to plastic? It just makes sense to me. So each coat, each one of these has a coating of a Gantz mixture, which I make, and the center core Gantz is just the mixture of all three of the well, actually I use nine different dry Gantzes, because what I do, because I have the bio Gantz, I have these are all pure Gantz powders that I've dried. So what I do is I dry everything first, and I have the 12 bioplasmas. I have the salted, the Epsom salt potassium mix, and I have just the natural Himalayan sea salt mix. So I have three different dried Gantzes in a powdered form. And then in the powdered form, I put them all together, and then what I do is I just mix a little bit of the all three of the liquids together, and then I just put a little bit of sugar in with it to make it a. Go ahead.
Yeah, could you just lower the thing? Yeah, there we can see it better. Thank you.
Oh, I'm sorry. Yeah, so just to get a nice pasty mixture like that, so that I can paste the plastic. That's what I do, is I just wipe it so that it's a nice sticky mixture. And the funny thing is, the Epsom salt, I showed those last week. The Epsom salt crystals, I thought would rehydrate, you know, because there's Epsom salt is it's a crystal mineral, and they stayed hard. That's in everything I got. There's the Epsom salt crystals did not rehydrate very well. They stayed more of a crystally, their same form. I actually had to kind of really work with them down, moving them down, and the big chunks, I couldn't use the big chunks. I had to move those aside because I was afraid that they were going to rip the plastic. So each one of my layers has a GANS. Each one of these units now that you're looking at here has a GANS layer in between each one. So as I went along and made these, so the first one, which would be my inner core here, is made with the mixture of all of them, which is the strongest one of them all. It's pulling it all in. Then the second metal that you're looking at here is zinc. And then what I did with the zinc tube, this is exact same thing. And that would be, that was the CuO that would be the on the zinc plate. The same way that I did the inner, I just pasted it up, rolled it up, and then the next process would be the aluminum. I don't know, the aluminum is really hard to get out. Oh, come on out there. Everybody wants to see you. Let me see if I can't push it out. The aluminum tube was the hardest one to work with. It was so flimsy. There it is. Because when you try to nano coat the aluminum, it has a tendency to flake. You got to watch it. You can't really put it in caustic, but you got to watch it because it'll can flake off bad to where you'll start to lose a lot of it, especially if it's a hot caustic.
Yeah, that's right. Aluminum will dissolve in caustic.
Yeah, it just goes away real fast if you're not paying attention.
Produces hydrogen when it does that too. Pure hydrogen. Yes. Nice if you need it.
So it's inside, and this is this tubing is also inside that, and it also has has the GANS coating on it. And then the third tube that you see is a brass tube. And once again, the brass had the CO2 on it because it's closest to the outside. And that's what I feel is going to, interact, or I feel that CO2 and the zinc oxide are the two things that should have been the outside on the, it's the most available resource for all of our atmosphere. So that's why I thought it should be on the outside. And then of course, the nano-coated wires, or, the coiled wire. And then I made the return wire on the coil here for the front end. And then of course, and then I'll have the back end will be your pickup. This will be your positive pickup. This is your negative pickup. So I'll have 4 of them. So what my idea was is that I had each one of these on the inbound of. So for these 2 coils, the flat coils, I see them as the positive coil. This is where I'm going to put the positive charge from the 1.2 or 1.5, and the charge will start through a capacitor into the coil. The coil will drop down into the second coil down here, and then outbound into another coil, which would now give me my positive feed for my GANS unit. And then the second unit, I'm going to have another capacitor, which this is just going to be an inert, I thought will probably be an inert until it becomes a loop back, because all I'm going to do is just loop it back into the earth ground, and I'll have a capacitor coming in and a capacitor going out, and the capacitor going out will be the negative side of my GANS production side. So this is all this effort here is just to make plasma GANs. This is just a thought of mine. I don't know, I don't even know if it was tried or anybody tried it, but this is just my thought. I don't know if it's going to work or if it should work or how the flow should go, but that's just my thinking, and that's how I kind of like to have fun. Is just to when you said, Rick, when you asked Lee how he gets his ideas, well, when I get my ideas, they come to me when I'm standing in the shower. I confirm my ideas in the shower. Sometimes I might be in the shower for 40 minutes just thinking about different flows and how things should go and how things should, and everything. All my entire other unit was all created in the shower.
Well, that's pretty good. Now we know your secret for getting information. We got Lee's secrets out of him. Now we find Mark's hidden inner secret, this shower.
The water.
The water. It comes back to the water.
So that's what I've been working on.
Great, Mark. Really good. So when are you going to make this connection with the ground system and so on?
Well, like I said, I just got done because on all the ends of the I've been using the two-part epoxy like Lee uses. It's nice. It really seals the ends, but it's kind of a long process to seal everything. So these are all sealed up now. Finally, I just finished working on them, and so now I do have the nano-coated tubes that that go on the end on the outsides of them.
Nice.
They're ready to go. And then on the for the middle of the balls for the inside of the stacker units, I got the little eggs. And the reason why I have, because those will be filled, this one actually will be filled with the CO2 on the top. And I have another one with the CH3, and then the middle one will have the combination of the mix. And then with the outside ring, like a lot of people like to talk about where you want to get, your different gradient. The outside here, I can put a different gradient. Like I'll take some CH3, I can put as many milliliters on the outside that will agitate the same thing up and down, where you get the gradient draw, because these were all soaked. These were actually soaked in GANS for almost 2 months. So these are all nano coated and GANS. So that's why I'm using these particular GANSs inside. And then, like I said, I can add different types of GANSs on the outside in order to make the agitation or the change to the condition. And I have a lot of you have more flexibility, I think, when you have the ability to be able to interject different types of GANSs at will.
Okay, there was a question about, does your internal coil not touch the aluminum part?
On the capacitor?
I believe so.
No, nothing touches. That's what the nano-coated plastic is for. You don't want it to touch.
Yep.
Correct?
That's
you don't want. Yeah, you don't.
Well, it depends on what exactly you expect, I suppose. If you're making a plasma battery, you might need it to touch in certain places through the nano coating. But with the capacitor, it probably shouldn't be touching.
Right. That's really all I'm not expecting it to be a battery.
Right.
I'm expecting it to give the power when it needs it. That's what a capacitor does, is regulates, because I think what's going to happen once my GaNs production starts, different GaNs will probably draw more power. I'm not really familiar with power because I've never made GaNs with power. It's all been with bubbles. So this is all completely new. I'm going sideways on this one. So that's it.
Right on. Thank you. Thank you very much. That's another update from Mark on his remarkable MagRav, I guess you might say. That's what you could name it. Mark's remarkable MagRav.
We're just having fun.
Space Stream mentions, as though in the capacitor all the nanoparts must be connected over aluminum. Or I thought that in the capacitor all nanoparts must be connected over aluminum. Oh, I think he's saying, so that would be like the nano-coated coil over the aluminum should be connected, I think is what he's saying, or physicality touching. Okay. This is what he seems to have gotten from Mr. Keshe, so I guess that may have been part of the original, but I'm not sure if that was in a plasma capacitor or a plasma battery. Anybody else have some clarity on that? What was in the original teaching about that? I think they did, I think they were wrapped over the aluminum, but not necessarily tightly or in intimate contact, as they say. And with the nano-coated copper, theoretically there wouldn't be any electricity at least going through.
I only put the aluminum in there for the element itself. Just the element particles itself is all I'm really hoping that I can pick up through the fields of the I mean, there's a lot of different elements that are in that little stick there. You just think about it: brass, aluminum,
plastic,
sugar, GaNs. Bio. I mean, there's a lot of stuff that's banging inside there. So I'm just hoping that it all can find a way to coexist and to do the things that it's supposed to do, have memory and give and take the way it's supposed to.
Yep. Very good. Any other questions? Oh, sorry, go ahead, Mark.
Well, I just, like some people want to really, you should do this. I know I should. I try to preference that. I understand. I'm outside the box. So when I do these things, I'm not really. I listen to Mr. Keshe, but a long time ago, we were told to go ahead. There's a gazillion sons. Sons of sons of sons. There's no wrong way to do things, and so sometimes my things are silly. And they're not exactly the way that. So I want to try to say that everybody should do the school way or the foundation way, And if I stumble on something, I'll share it, and I'd be glad to show it. And I just don't want people to hold me to this, to where, you know, this is a fun group. This is fun. This was just stuff that we guys got together and threw things together.
Yeah, it's not necessarily sanctified by the Keshe Foundation as far as the actual techniques go, or the concepts and so on.
Yes, if it ever got to that point, I guess I would have to stop presenting, because my line of thinking, you know, is a little bit different. I try to hold the principles of the foundation, but you know, just looking at my stacker unit, you know, that's kind of, you know.
You've gone through it many times and shown us, you know, where you've applied the concepts and principles that usually right after Mr. Keshe has talked about it, the next week or two, you've incorporated into your machine there. So
I try, but like I just don't want to get in trouble or get in trouble with the foundation or anything like that. This is, you know, when we first started, I started out 2 years ago, was just a bunch of guys getting together and having some fun. So, you know, it's getting very serious. I know it. I understand it's very serious stuff now, and you know, it's almost, sometimes it feels like it's out of my league now, and I shouldn't be doing it, but I can't stop because I'm having fun.
Well, you know, it could come a point where something clicks and all of a sudden we have the ignition key inserted and the units come alive and start doing their levitation gig, or you know, generating huge amounts of power or whatever. And because we have been working with these ideas and concepts and trying to visualize and feel the fields, then we're automatically already kind of looking at things that way. We don't have to make a big jump when some new device, maybe it isn't even through the Keshe Foundation, somebody invents some plasmatic device with a certain configuration. We can probably look at it and say, oh, I can see how that works, because it's, you know, these three reactors are interacting and causing the free plasma in the middle, and because we already know the concepts and have been working with trying to feel our way through these through the design end of it, we sort of have a leg up on that. And it takes time. It takes, you know, more than months to get a handle on everything. Whoa, my eyes are going blurry. There we go. Your little egg hatchery. Those are cute little egg shapes there. Where'd you get the egg shapes again? Sorry, you're muted, Mark.
You can get them off of eBay or any, you know, what's the other one?
Amazon?
No, I seen them on the Chinese one.
Alibaba.
Alibaba, yeah. They're just plastic designer eggs.
Okay. Mm-hmm.
And then I just nano coat them. You know, I put, you know, heat them in caustic and stuff. Try to get all the yuck off them that I can.
Anybody have any questions for Mark on his things we see here? Or otherwise?
Thanks, Mark.
Just having fun. So hopefully by next week it should be up and running. I have my containers are all cleaned up. I had to get some new ones. The last ones were getting so many stress cracks in them. I had to finally dump them after just 4 runs. I hated to get rid of them. They were so nice, you know. They were just getting broke in. But all things must come to an end. And 4 is it just seems like 3 and 4. 3 to 4 just seems like it. So I had to start over. Got some new containers, and like I said, the capacitors should be done, and we'll see. We'll see what happens. It should be ready by next week.
Great, thank you, Mark. Is there anything else you'd like to show about that, or something else, or what you got there?
Me?
Yeah.
Oh, well, no, not really. I mean, I got, you know me, I'm working.
You can always pull an ace out of your hat there somehow.
Oh, yeah.
But, okay. Well, is there anybody else that has something they've been itching to present here at this point in time and needed to do so before they go to bedtime or go to work or wherever else they have to go? That does happen from time to time. Apparently not. Okay, well, that leaves things wide open here. If you want to carry on with something there, Mark, you're welcome to. Otherwise, we can open up to another topic of discussion, or we could wrap it up for tonight if everybody wants to stay quiet.
I don't have a lot. I mean, other stuff like we looked at last week. I mean, I'm still working on. I'm working on that central. You know what? I bought that epoxy that Lee uses now, and it works a lot better because I couldn't get those plastic tubes to glue together. But with this new epoxy, this two-part epoxy, it seems to be a lot better than I had before. Now at least I can put my core center for my bigger unit together. Yeah, I'm still working on that one.
So what's it take to set up that epoxy? Is it a half a day or something maybe to set up properly?
It's a 3-hour cure. It's a 15-minute to the touch.
Okay, yeah, that's not bad.
Yeah, and it on the chart, it's the best one they said for vinyl and plastic. And I'm telling you, I can't pull it apart. It's hot. I tried that, the high temp hot glue, and it didn't work. Here, I'll show you. Here. Oh, I just cracked it. Darn it. Figures. Don't touch that one. I mean, it's pretty tight, and that's only just one seam down. That was my first coat on there, and I just cracked the first coat, but that's okay. But like I said, this is my central core, and I finally got it to where I could actually glue it together. And I got the, I don't know if I showed it last time, but this is going to be my idea for that central core for my bigger unit.
It's not on screen, Mark. You may need to adjust your camera, please.
Oh, I'm sorry. So like we were talking about last week, this is my central core for my bigger unit, where I can put all the 4 different ganses in there, and then this will be my power unit in between, and then the like I said, this was made by one continuous wire, and I cut it right down the middle there so that it would be agitated. Once I put it together, it'll always want to come back together, but it won't be able to because I've got a gap in it now. So that's where the gradient will come in the middle there for that one. And that's the 4 core central core for my bigger unit. And what on the bottom here, that's going to be for the for the piping, and you'll see that later. But I'll be able to put an air tube in here, and I'll be able to actually, if I do make hydrogen or whatever extract that comes off of my unit that's actually making GANs, it'll have a way to get out. It'll actually have a way to go through a vinyl tube, come down through the bottom here, and then exit on off of a check valve that goes on the end, so that I don't get air into the system. The check valve will let air out. Check valve will let air out, pressure out, but it won't let pressure in. So that way that if anything builds up in the system that I don't want to build up, or I do want to build up, it'll have a place to go. It'll have a place to do whatever it needs to do. If it wants to leave, it can leave, or it can bubble, or it can, hopefully it'll glow. That's what I really want to see, is a nice glow inside this central core. Yeah, it's all fish or fish from a fish aquarium and stuff. Uh-huh. Yep. Cheap, easy. Yep. And then I just like I said, I just epoxy. Oh, well, that one's gone now. So, but anyway, I epoxy the top down in the bottom, and then the top here, just to make a nice seal so that I don't have any leakage. Same thing on the bottom there.
Yeah, nice idea. It's good to keep the pressure able to escape with, especially with a glass enclosure, of course.
Right.
But plastic as well. Because you could have hydrogen gas or other gases build up inside, especially if there's some remaining caustic and a bit of aluminum and so on. It's pretty much a magic combination to build up hydrogen gas.
Exactly. And that's what I was worried about. Because when I put these feeder lines, I got them all taped. Because as you remember, I made these that go, these actually go inside. And these will be, this is actually
inside. We can't see the top there. Okay, now we can. Good, thank you.
Okay, so what you're looking at here, there's just, that once again, that's at 12 gauge wire. There's a piece of carbon on the bottom that's going to end up at the bottom, and then this will be my three mixtures. There's a small piece of zinc. There's a small piece of iron, which is an iron. I made a copper or a coiled iron. Then there's the copper, zinc, copper, iron, and all three of those will be down in the tube. So that's what's going to, because I don't want to, if I'm going to space, I didn't want to have to worry about going home and get my GANs or filling up with GANs. This is how I'm going to make the GANs. We make the GANs with the same thing. So the GANs will be made in the tubes here. Throughout each one of the legs will have each one of the GANs. That's the three of them. Then you have each one of them as an individual. Each leg has an individual. This was a whole piece of zinc. So I'll get CO2, zinc oxide, because it'll be carbon, zinc oxide out of that one. And
so you'll have salt water, I guess, in the tubes, right?
Yeah. Yes. Mm-hmm. And then I nano-coated the insides of the tube too. Not the outside, just the inside. And then then you have your your whole iron wire. And so each tube has a representation of each mineral, so that if I ever had to, like I said, I'm not going home. If I'm way out there, I don't have to go home for my GANs. I'm depending on this unit here to make my GANs. And like I said, there'll be so I have 2 ports for each leg, the electric leg, because I'll still be able this. The rest of this wire is going to goes to feed each one of the plates. So each plate will have, like, each plate represents each one of the units, or CO2 or CuO, or because these are hollow tubes inside. You got to remember, these aren't your normal stacker units. Those have a plastic tube where I can fill the plastic tube with the wire that goes inside and outside. I don't know. There's probably a lot of people don't remember it, or some people do remember, but it's each plate is a stacker, but I just took the stacker apart and put a tube in it, and then put your actual wire through it, and it goes in the T and then comes back out, so that I can fill each tube with the GANs material that I want inside the tube. So it goes inside, outside, through the GANs material, back outside, through the outside, back on the inside, through the top GANs material, back to the outside again. And then it'll be fed by this, by the leg. So each one of them will have a feeder and a leg, so that it'll always be able to feed. And then what'll happen is, what I was worried about, the second output of this has to have some way to off gas itself. Actually, what you see is the red line will come out this way, and you'll see a T come off of here, or an elbow come off the top, and then I'll have tubing come off there. It'll come down, 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 and then that tubing will go into the bottom of my central core. One of these. Each one of these will be fed through here. And I don't know if I can get one. Maybe I can get one of these in here. See, there'll be 4 of these inside here. It fits perfect. And then I'll have because this one here is going to be your positive and negative in the very end. Everything will come back to the central core. It'll all be fed back into here. But these will all be liquid cores. So hot, positive, they'll be hot and negative, positive and negative off the matter material, but off of the GANs material is what I'm really hoping to really collect energy from in all the tubes. And then we can go on from the arms and legs and all that stuff that I got, all the outriggers that go with it. I know it makes 100%.
I think you're going to have a big, thick user manual for this thing, and parts manual and so on.
You think so?
It's all starting to become rocket science.
Is it really? It's really, you know what? Yeah.
Well, in a way, it is. It's simple, but at the same time, there's a lot of detailed thought and parts that have gone into this. So it's great to see the progress as we go along.
That's why I like to keep showing it, because people come in and out and they'll look at it. As time goes on, maybe technology we'll be able to synopsis all together. It's been a 2-year process, wouldn't you say?
Yeah, right. Probably. Yeah.
So I never had a manual.
That's right. There was no builder's manual on this one.
No. And this is all just stuff that we've learned throughout the years with Mr. Keshe.
And it's starting
the legs and the arms and the capacitors and the
whirling parts, and it's quite a creature. Once it gets going, it'll probably walk across the floor, no doubt.
Well, because it did move pretty good.
Yeah, you had some some wild flailing appendages.
To it. We had it going at that one at one point.
Yeah, yeah.
So that's what we're working back. You know, it's
starting to make more and more sense now. So maybe once it makes sense to all of us all at once, maybe that's when it'll actually work as it's designed, and we'll think, gee, well, that was easy. Next.
That's gonna be nothing. So
I can't wait.
That's my thought process.
Very good. Very good. Alrighty.
Yeah, give you a full on, because this is what I look at all the time. My little shop. My little shop of plasma.
Yeah.
We're gonna get there. I know we are.
Right on, Mark. Thank you. Anything else specific, or shall we go into Space Stream? Wanted to tell us about how he healed his leg muscle. He or she? I think it's a he. Is that cool, Mark? Are you pretty much finished with your
oh yeah
thing? Other than we're in pondering and pondering meditation mode here now. With it's a good shot with your shop there. I like that. I'll go. Okay, let me explain this about Space Dream. Says, I can tell you how I healed my muscle in the leg by GANs. I got an injury in 2 days. It was completely recovered. It was a miracle. Says I just soaked 3 pieces in GANs and wrapped them around the leg. All parts were covered by plastic wrap, so they did not touch each other and no contact. So it was like 3 spirals around the leg. And the wireless energy detector beeped like crazy. I believe it was a huge amount of energy rotated around the leg. Doesn't remember which direction I wrapped it. It was about a year ago. I told my co-workers, and no one believes it's possible. Not in 2 or 3 weeks or even months, but 2 days, amazing. So his patch, he ripped up an old shirt for 3 little pieces, like 4 inches wide and 2 feet long. First was CuO, then CO2, and the last was CH3, if it matters. Okay, so that's interesting. Recovery of a leg muscle. Okay, what else we got here? Peoples. I don't have too much to show this week. What do I have?
Rick, what was that helmet that you were wearing in the introduction of the group?
Oh, let's see if I can find that. I'll screen share it here. This was a thing that Jay had put together for that I can use as if there's a technical issue or we have to have a pause, station pause. And he used a picture out of one of my plasma reactor groups. I think it was maybe a year ago or somewhere around there. And he had the on-air part here and so on. But the helmet is a standard welding helmet. You don't usually put glasses on outside the helmet. You wear them inside. But it was also, I know, it was Halloween. That's what it was. I think it was Halloween, I think it was just last year. So it would have been last October, yeah, about 8 months ago or whatever. So, yeah, I was just sort of playing around with welding helmet and gloves and the plasma. Oh yeah, there's earphones on outside the helmet as well. Just gives it kind of a robot-y kind of look. Anyway, it was all for fun, and Jay took that image and decided to put that little thing together, which is very effective. Thank you, Jay.
It's really cool. Thanks.
Alrighty. Space Dream continues about his legs, says basically after one day it's got recovered about 95%, and after the second day I just forgot about the problem. Thanks, Mr. Keshe, for the knowledge and everyone who's involved in it. Very good. There's lots of testimonials on the Keshe Foundation website, the main website at keshefoundation.org. You can scroll down in the menu for the testimonials, and there's lots of them now on many different categories. Everything from health through to power and agriculture, that kind of thing. Okay, what else we have, people? Anybody else with something to show, share, comment?
Hi, this is Denny.
Hi, Denny.
Carrie Ellis was talking to Mr. Keshe last Knowledge Seekers and mentioned the copper rod. Mr. Keshe mentioned that the copper rod.
You mean the carbon rod?
Yeah,
or
yeah, no,
carbon rod?
I meant carbon rod.
Okay.
Excuse me, I said copper. The carbon rod, he mentioned that its effectiveness is to produce large amounts of energy, but there was no follow-up to that particular response from Mr. Keshe. Does anybody have any knowledge of what he was talking about? And when he brought that up, he said he had talked about it one other time. I kind of vaguely think that a person uses two carbon rods, one is polished.
Well, didn't Armin tell us to polish the carbon rod?
He did it one time.
Yeah, I remember something about that. Mm-hmm.
But so this purpose was that it would create a lot of power. And, so if that was the case, it would.
But didn't he also say that it wasn't, the power wasn't good to consume, that type of, with the carbon rod isn't good to consume? That's
Yeah,
what worried me yesterday when I listened to that. When she was, because she kept on asking him, like, to get him to confirm it's okay to have that in the GANs, and he kept on kind of favoring away from it. He said the carbon rod was good for certain things, and but too much carbon, he said, not good for human consumption, or not good for GANs that you're gonna. I thought that's what he said, or the point he was trying to make. Did that come across to you?
I believe that's true. Mm-hmm.
I thought he was saying that about the battery. If you used the zinc plate on it and the carbon rod, if you washed it and polished it, use that was a great food source.
He did mention something out of the carbon rod that's in a battery. I remember that part.
The carbon rod or the zinc in the battery, the zinc container.
The zinc is the coating on the outside of the battery?
Right. Anybody else remember any details about that?
well, I was hoping Shandor might be able to add something to that, but
Well, my thought behind that, Denny, was that's why I have it on the bottom of each one of those wires, is that I'm not going to consume that. I need that for my core, my energy core. You know what I'm saying?
right.
Hopefully that, because my essential core is my motors, my heartbeat, is my lungs, and everything. Right? What you're looking at is got to be the middle of everything. That's what I'm hoping for.
Shandor, did you have something you wanted to add?
I just dropped here. Sorry, I woke up very late by 9 o'clock because I went to bed by 4 o'clock. So I just dropped here, and okay, it's okay that I'm invited to add something, but what was the subject before? I just came with my coffees.
Okay. We didn't mean to arouse you out of your slumber there or anything, but...
Well, we would like to say good morning.
So good morning, everybody, or good evening, or good night, whatever time you are in.
So perhaps we could explain to Shandor what the question to Shandor was, Denny. Maybe you could be more specific.
All I remember was that Carrie Ellis was talking to Mr. Keshe, Last Knowledge Seekers, and the topic was brought up about the carbon rod.
Oh yes, I remember. And now about the carbon rods, I can say only one thing from my experience. I don't touch them for the purpose of making grants. I have no any experience with trying to make GANs by carbon rods. I prefer to follow what Mr. Keshe taught us about nanomaterials. I don't know if that satisfies you.
No, but I'm glad you said that too. The thing that he was saying, that the carbon rod, if you use the carbon rod in a certain way, it creates a lot of energy.
Possible. For instance, if it's in the middle of a zinc battery, it makes sure a lot of energy. You know, it's in the middle of a battery.
That is,
so yeah, is a very good use for the carbon rod. It makes a lot of energy. You see, it's a zinc carbon battery. For sure. You know, for the first time I've heard of the gentleman's Alvis Liepa's presentation about the carbon rod. Maybe I don't remember well, but I remember that he heard that the nano layers are graphene, and graphene is made of graphite. So graphite is carbon, so let's use carbon rod. So this is the theory behind which I remember. Maybe I missed something, so please add anything if you know more. It's okay to use carbon rod, to use diamonds, to use gemstones, whatever, but please explain how it works and why it works. In that case, we can be clear about it. I don't remember if I got, maybe I missed the explanation of why it works and how it works.
Yeah, I was counting on you catching that. So I was just hoping you had a chance to take that in.
I remember only the logic of carbon, no, not carbon, sorry, of graphene, sp2 and graphene. And graphene is like graphite, or graphite may contain layers which can be taken off as a graphene, and graphene is carbon, and the rod is also carbon, so that's why carbon rod. I saw somebody, believe me, he's not anymore with us. I'm very happy for that. We had somebody who was very much seeking a lot of attention. Recently, I think he has got a lot of attention from police in some countries. He was such a nice gentleman who once posted in a study group a recommendation for this carbon rod method, showing a promotion of all sizes of carbon rods, like the fishing rod, carbon fiber rods. So that's the logic behind. Some people who hear something and do something. Of course, Arvi Sliepa's method with electric current through the carbon, yes, it does something very interesting. But it does very fast at high energies, and I think it's different condition compared to that when you have 10 nanoamperes, not even microamperes, to salt solution. For instance, here are two plates, one of zinc, the other of nano-coated zinc. And as you see, it's producing very nicely. So here is the end product. This is made with potassium salt. This is made with sodium chloride. And I see certain characteristics for this one in appearance. I made, when I was a kid, yes, I used the carbon rod to make electrolysis of brine. I made salt water, salt solution, brine. I put the two carbon rods from two batteries like this, and I put them to a 4.5 volts battery. I gave it 4.5 volts. And I was watching how much chlorine gas and hydrogen gas it produced, and it produced bubbling, some green, yellowish foam like a green dragon from a tail. And I smelled the breath of the dragon because of the chlorine which came out. I almost poisoned my parents and brother with so much chlorine produced, and something deposited at the bottom, of course. But I was a kid of 9-10 years only.
I'm going to jump in here for another quick thought. And when Carrie was talking about, well, do you really need an LED? Can you do without an LED? And
Of course.
Well, Mr. Keshe jumped in with, you can use a twig. Take off the outer layer and make sure that the twig doesn't dry. So you may want to put it in the water, and you might as well use liquid plasma if you're going to put it in. And then when you connect the two wires, connect one wire above and one wire below, but make certain that the twig doesn't dry out. And he said, yes. Do you remember that?
Yes, yes, it was discussed in the evening in the English language private group, late evening, late night. You understand, what's a fresh twig? It's moist. So it's slightly conducing a very little electric power. Slightly, if it dries completely, it will become a very good insulator.
Right, you can use a potato and the starch and turn it. Keep it live.
What I used to use two twisted nano-coated wires. I show you once more. You can see that. This is what I used to connect the plates. And it does almost the same thing.
That's what was originally recommended when the whole thing first started years ago.
Yes, you know, the purpose is to reduce the current. You interpose a high resistance of the order of mega ohms or tens of mega ohms, and current equal to voltage divided by resistance. Now, between two metal plates, different kind, be it nano-coated, one and the other not, or both nano-coated, you still can measure a little voltage when you put them into the salt water. So before to connect them, try to put your voltmeter and measure what's the difference of voltage between. For instance, between nano-coated copper and zinc, you will find something 0.6, 0.7 volts. It's only not more.
Is that one nano-coated zinc, one non-nano-coated zinc?
Not in my example, but in that box, yes.
Okay. Did you ever experience seeing like the little whisper of smoke going across from one non-nano-coated to the nano-coated?
No.
Oh, I have a video on it where you can actually see the transfer of energy from a coated to a non-nano-coated.
Very good. How much salt did you use?
That's with the biosalt, the 12 biosalts. And that was, I have it written down, but it, because Armin told me to make it, I use Himalayan salt, and then he told me to use 5 milliliters or 5 grams of the bioplasma salts, the 12 bioplasma salts. Have you worked with that at all?
I understand. So use something special. So back to what you put in between the two plates, you can measure the voltage. You will find some little voltage, maybe 1/10 of volt between copper and nano-coated copper, maybe 10 millivolts or whatever. But all still you get a difference of voltage. So now we know that from Ohm's law that the current is direct proportional with the voltage. So you have a higher voltage, you have a higher current. You have a lower voltage, you have a lower current. But it's inversely proportional with resistance. You have a higher resistance in between, you have a smaller current. You have no resistance, it's a huge current. So that's why we need to put something to limit the current, because otherwise you will produce such electrochemical reactions on matter level, and you will not produce the plasma processes which you wish. You will have a flow of ions and electrons and whatever, so pieces of metal will go from one to the other, which is called electrolysis or galvanoplasty or whatever. So interposing a resistor, be it a wet twig or LED or twisted nano-coated wires, or a piece of graphite from a pencil, or a resistor of 1 mega ohm or 1 kilo ohm, does not matter, it's reducing the current. Now the purpose is to keep the currents low. As Mr. Keshe told, in nature there are no volts and amps. In nature, in the biological processes, there are millivolts and microamps, and I would say it's fractions of microamps usually. So now you can calculate very easily. So if you have a multimeter, do you? Have you got a multimeter? So you have the two plates, which are in salt water, however, and you have them not connected yet. Just put here your voltmeter, digital, analog, does not matter that it should be enough sensitive, and measure here the voltage between the two. You will find here something 0.2 volts, 0.7 volts, or whatever, depending on the metals which you have. So now, knowing that voltage, you can see what effect has a resistor of a certain value. So current equal to voltage divided by resistance. So let's say current equal, let's say 0.7 volts, because we have a zinc plate and a nano-coated copper plate, and this is what you measure there. And you have to divide that 0.7 volts with, let's say, 10 mega ohms, which you measure the resistance of your twisted nano-coated wires, but usually it's 20 mega ohms or more. So that divided with 10 million. That means 0.000000007 amps. So this means here are the milliamps, here are the microamps, and this is the nanoamps. So this is 7 nanoampere. It is 7 nanoampere only. If you use an LED, the same thing happens. If you look at the diagram, the specific current voltage curve of a diode, that usually looks something in this way. So how the current changes according to the voltage. So here you have plus voltage, here you have minus voltage. Okay? You have to reach the opening voltage of a diode in order to open it, in case of an LED to see a light there, which it can be such a 1.8 volts or 2 volts or 3 volts, depending on the color of the diode. Let's say it's a low voltage one, it's a 1.8 volts. So how you compare 0.7 volts to 1.8? You will not get a voltage to open the diode, so it applies 0.7, which is somewhere here, that which you measured, and you see for that little voltage, oh sorry, it should be on the positive range, not on the negative. Let me draw it again. Just a second. Just a second. Okay. So here is, this is the current, this is the voltage, and this is the curve. Sorry, actually this has to go through that zero there, okay, and it goes like this here. No, Oh, I think I drawn it well. Yes, so this is the opening voltage. You don't have the opening voltage, you have a very small voltage, you have a 0.7 volts, and the diode would need 1.8 volts, so it will work somewhere in this region, where the characteristics in this region, down to the breakdown voltage, it's something linear. You see, it's just a line like this, like a resistor. You know, this slope, it's bigger or smaller, you have a smaller or higher resistance. So you see a very tiny variation of voltage will make a tiny variation of current here.
Sandor?
Yes.
Is what you're explaining there, is that all made with power? Are you making that with power?
Which power?
I mean, like any a power source.
Yes, of course. So you have two metal plates in a salt water. You get a voltage in between. This is natural.
No, what I'm asking you is, do you add a power source to it, or you just naturally?
Why?
I don't. No, I don't.
Why should I add?
I don't either. I just use a bubbler.
Why should I add anything?
You just let it sit.
So my purpose is not how to give more power in, how to reduce that electric power which goes through.
So it's almost like making a PMP or a transistor, sort of?
No need. You have a high resistance in between, and that's all. You use the diode in its linear characteristics, where it manifests like a resistance of very high value of the order of megohms.
Maybe if I could share my screen, maybe you can comment on something that because here's the video that I was talking about, because I make my GANs and I don't use any power, bubbler, water bubbler.
I just thought I'd have to make a little video of this here. Look at this. Do you get your zinc on zinc? These are both zinc, one nano coated, the other non-nano coated. I mean, just a stream of energy going from the one non-nano coated on the closest to us, and the farthest one is the nano coated. The non-nano coated one is the one that's creating the smoke or the stream of energy, whatever it is, going towards the nano coated one. I just thought it was pretty interesting to watch it. This is no power, no electricity going to this. This is just zinc on zinc in my little GANs production.
And you can hear the bubbler in the background. All there is there's a small bit of air going in the back behind the plate.
Once again, I thought it was pretty cool just to try to catch it. You know, without the light, you can't see it at all. But once you put the light to it, that just brings it to life. Yeah, I just thought if anybody else wanted to check out theirs and see if they got smoke or energy going from plate to plate, give it a shot, see what happens. I just thought it was pretty cool looking. Means the actual fans going from one side to the other. Okay, have a good one.
That's all. That's all I got. But actually, I do have another picture where I took electrical readings from that actual unit that you were watching. And this was the same thing that you were just, oh, maybe that's not great.
So, Mark, what did you connect one plate to the other with? What was the system you used?
Well, this, Denny, just had the, right here is, that's where the LED light is. And that had the LED with a resistor. And it was a, the resistor was for the, it's a 1.2 LED resistor and light. It's like a little kit that comes with it. So that's the, you know, that was the crossover, the resistive point was on each one of my units. That's where that was. And I'm almost sure that this is the one that was creating the smoke. It was either this unit here or the one next to it. But
what are you showing a picture?
We
don't see a picture. I'm not seeing it.
Oh, maybe did I stop share?
Mm-hmm.
Is it there now?
There we go.
So this was the unit that you saw the smoke come, oh no, that was zinc on zinc. That's right. Which was this one here, raw zinc and raw zinc with regular zinc. I don't know if I had a picture of it. Darn it. Let's see. Yep, right here. Raw zinc, zinc on zinc. Raw zinc and nano-coated zinc. That and there, the LED is in on this side, and on this side I was taking the reading, and then I took I took the video pointing down. But this was, you know, you can see the reading that I got off of this, and it was consistent. And it, you know, I had, you know, that my tester here is at that's a little bit more than a half a volt that's coming off there. Because my tester's at, you know, that's 200 millivolts right there. So I had it blasted out at 200 millivolts, so I had to kick it up to the 2, which moved that decimal point to more than, because this is only 200 millivolts. This is 600 millivolts. So 600 millivolts is the equivalent of about a half a volt, right, Rick? Or Sandor?
Sorry, I was away from the. Could you say that again? How much?
Well, 200 millivolts is where the arrows, you know, I had it, you know, it's down here, 200 millivolts. And then it just overloaded, so I had to kick it up to 2.
Right. Yeah, it's 0.603 volt, which is 600 millivolts. Yeah.
So this unit here, which you've seen the smoke coming across, has no electricity going to it. Nothing else is touching it. It has the LED light with a resistor on it. It's a 1.2. You know, to turn it on, if I put a power supply to it, it takes 1.2 millivolts to light this one up. Is that right? Yes. No. 1.2 volts.
Yeah.
To light that up. So it's a, you know, I was creeping up. You know, I didn't have much more to go to get this light to light up on its own with nothing else. But that was what you were seeing. This is the unit that you were seeing, and like Sandor was saying, and that's why I didn't mean to butt in on this, but I was hoping he could comment on why this was doing what it was doing, and the smoke that you were seeing that was going across from the non-nano-coated to the nano-coated with no electricity and only air going into it.
And it was interesting that the bubbler was not disturbing the flow of the smoke, but you could see particles moving, that the bubbler was moving.
Yeah, without a bubbler, you see everything is less dynamic. So sometimes without a bubbler, you see that things are sticking to a plate or to the other, and with the bubbler you put in motion all the things. So besides we add some fresh air, and if you adjust it well to be not too strong, not a very strong bubbler, but a very mild bubbling, in that case it helps keeping everything moving. In the same time, if you have that moving, you will see that the amino acid which is collected on the top will mix into the liquid in a better way. So if your purpose is to mix it up, in that case you can use a bubbler. Once I use not a bubbler, but I use the water recirculator pump for fish tank. It was producing very nicely, very fine. So the created gas, which was created near the plates, in the space between the plates, got moved and kept in motion. But the side effect was that I had no amino acid to harvest from the top until I stopped completely the pump.
Yeah, I don't get much amino acid until the pump stops. The last week and a half, yeah, maybe 2 weeks ahead, because I do make my ganses in 30 days, 30, 35, 32. But the last week or the last 7 days, I take the pump out and stop the bubbling so that the amino acids build up on the top. Because you won't get any if you leave that bubbler going. Well, I don't anyway.
Well, you might get them mixed in with the salt water.
Probably, like he said, you know, in the making process, it probably does get in there. But I just thought I just wanted to be calm, and then I have a main valve that I keep on dialing down as it goes. So that's good observation on your part, Denny. That part, it's at the very end of the process, and the air is, I mean, you can hear it, but that's 6 times, you know, you're hearing it, the air coming out of all of them, and it's just a bloop, bloop, bloop. I don't have it at towards the end. It's not agitating. It's just adding air to it. And I do nano coat my air tubes and my air valves. So anything that passes through that air tube is already nano coated. But my question to Shandor is: do you ever take a electrical or meter reading on your containers your GANs containers that you're making GANs?
Regularly, I don't need to do that because I know the values from the experience.
Well,
but
I do it just.
If I want to see how much is, I can put. I don't use to monitor it.
Well,
so now to understand why the copper oxide GANs is produced so slowly, see the voltage between copper and a nano-coated copper in salt water. You will see a very tiny difference. So you will have a very low current anyway.
Well, this one almost got me a whole volt, almost a volt's worth of energy, and I still don't have any electricity going in.
Yes, it's between plates, but you have the nano zinc and the copper.
No, this one was different. This one was nano-coated copper, carbon, and a raw copper.
I understand. So it's the difference between copper and carbon, which is bigger.
Right. Probably the most the dynamic in that solution is the carbon. The high dynamic, I should say.
Yeah.
In what do you call it? Batteries and galvanic responses, I guess you call it. They usually use carbon as the, what do they call it? The standard electrode, I think it's called. So it's like the one they measure the other metals. They measure from carbon like being the 0 point, and others are measured according to that. So if you were to put any any metal together with a carbon rod in a saltwater solution, you'll get a certain voltage, and that'll be a standard voltage according to the metal. So different metals will have a different standard galvanic measurement, and then you can use different metals against other metals to get the greatest difference between them, the greatest potential. The greatest potential gives you the greatest voltage. Like lithium batteries are popular because they have a greater potential per cell. So there's more, more energy can be put into them.
This time I'm not going to use carbon at all. No carbon. All plasma, 12 plasma salts with plasma energy. This one's going to be a souped up run.
Right on. Souped up run with but not a souped up rod.
Maybe one. I love that carbon.
I hope we have I want a carbon-free future, thank you. I'm zinged out from too much carbon this week, and especially today, too much driving, and the carbon is getting very thick out in the world. More and more vehicles all the time. Fortunately, they'll all be gone in a few years, not sooner.
Mr. Shandor, you were
Yes.
you had one time a demonstration of an anomaly that was going on, and was it in your it was in one of your tanks. Do you recall that anomaly? And did you
What was the anomaly about?
I don't know, was it black stuff that was going to the, can you recall it, Rick?
Which of the experiments which I have shown, because there are quite a few.
I can't remember it. I was just hoping that you did, because I was wondering how you resolved it. And what was the final result? Was it a again? It was a were you nano-coating something at the time?
So recently,
Go ahead.
Recently, I did a nano coating in which I measured exactly the quantities of water and caustic and potassium hydroxide, and I inserted some pieces of zinc to see how zinc reacts to that concentration of caustic, and it was beautifully nano-coated. So later I used for nano-coating zinc plates in the same way. Some people had issues with zinc, that they said it was molten in, or melted in American dialect into the caustic, or it became brittle, and I believe that it's achieved only when it's a high concentration. So my caustic concentration is something around or below 5% only. So for 1 liter of water I use 40 grams of sodium hydroxide and 10 to 15 grams of potassium hydroxide. And I had 1 liter of boiling water, so make the ratio. So you see it's around 5% only. And that makes a very good nano-coating, and it doesn't harm the zinc, so it works on zinc too. So
it's very, thank you for sharing.
So you see here is one, for instance. It's time to take it out. Now you see from the top some caustic has fallen on it, so that's the white spots. It's a dried caustic from the top, but the color is nice.
That's nano-coated zinc?
No, this is nano-coated copper. Nano-coated zinc is already in production. And you see, I put it in such a way that it doesn't touch the mesh. It touches only with the corners. It has some small legs. But the better is to put it vertically, to make some support for the couple pieces, bigger pieces to stay vertically. And you see here, this is the dried caustic on the top of the box. Don't touch that. This is a bare hand. Outside is no such thing. And you have to understand, when you finish the nano-coating, it's time to wash thoroughly your nano-coated pieces to remove all traces of caustic, because you don't need caustic into the next process. You don't want to cross-contaminate it. It was told by Mr. Keshe in the 173rd Knowledge Seekers workshop. So many people do everything fine, but they miss to clean, to wash out the caustic residuals from the plates, or they miss to wash out the salt water from the against, and they wonder why they don't get the desired result. Because they have into the formula something left over from the previous process which they didn't remove. Now to wash it out, remember those who had a photo lab in the old years, in the 70s or 80s, with, you know, when you had trays with chemicals and you put in one tray, in developer, you put your photo paper after it was exposed, and after that you have to put it into the next chemical. In between, always you had to rinse it into another tray with clean water. So clean it always, and at the end also you have to clean it. So you can put, let's say, 3 boxes like this. First wash, it takes off the most of caustic. Second one takes off the caustic which is left in the diluted solution, and the third, it cleans it up better. So it's an easy way how to do it. If you rinse it in 3 different clean water buckets or boxes, in that case, probably you have removed that. When you remove the salt from the salt water, it's more difficult, because there are small particles and always it keeps some liquid. So here you add water to the top, you let it to settle after you've shaken it, and then you remove the excess of water. Again, you add fresh water, let it settle. Again, you pour out the excess water, and you do that for 5 or 10 times how much you need to clean it, until you have no salt in it. This is important.
Hello, Mr. Sandal. I'm Chin Chin. Hello. I'm a new student. You know.
Yes,
Hello?
hi. Yes,
Yeah.
hi, we hear you. Go ahead.
Yeah, because I know we have studied in the conventional physical. We know electricity, intensity, resistance, and everything. But now to forget is very difficult. Everybody have to leave the all physical to adapt to the new plasma. This is a very difficult way. I know, but one thing we have to first to be patient. Second one to learn deeply, not only I know I try to do, but you see everybody want to have a quantity, not the quality. This is a problem. That what I thinking that.
You see, those persons who are selling some products, they are interested often in producing quantity. Some of them, not all. But those who you say on eBay, or they have a web shop and they are selling different kind of products which contain such a GANs materials, they are tempted to accelerate the production in order to sell more and make a more profit.
Yes.
You see also the food manufacturers. So before, the sausages have been made of meat. And today's it's made of many other components, including very odd chemicals like phosphates, which you used to put in detergent in the washing machine, but now they put into the sausages.
Yeah, why
and
I say
white powder which gets swollen if it's added water, and of course that has no taste, so it needs some flavors. It has no color, it needs some colors. It doesn't preserve well, so it needs some preservatives. And
yeah, why I say
somebody pointed me recently that he had seen on eBay somebody who is abusing and misusing Keshe Foundation's name.
Yeah.
You understand? They're selling all kind of products, and said, in case if you have complained, go to the Keshe Foundation, not to him. He takes the money, and the Keshe Foundation should take the blame. And what's very odd there, that he has such a small spray bottles. Just a minute, I want to open that link if I will be able to find it quickly. He has some spray bottles with GANs. So what are you doing to spray? What are you going to spray with it? And between them, it has such exotic GANs like lead GANs in a spray bottle. What use for?
Yes, I know, because why I say to you now, in the world they make for the quantity, not the quality. The first one, and the second one for the interest. They want to keep money faster.
I have interest to have you get the knowledge,
yeah,
and to help others and to make a better future, make better survival.
And now I'm a new student, but I try to keep the good way with the passion and to have more knowledge and to do something good and quality.
Okay.
I see too much people work. They have intention to make with the like electricity with the, but they don't custom with the plasma. This is I'm you know I'm very amazing by the plasma, but I see too much people work with the electricity about like they make only electrolyzer. They don't like to make with the plasma.
Yeah, that's a different thing.
Yeah,
Look,
I see.
I'm trying to share my screen.
Yeah.
Do you see that? It's abusing Keshe name. It's not endorsed in any form and shape. We don't know how these materials are produced. We don't know if it has any quality control. But you see, giving such a spray bottles that you can use, for instance, for health or whatever. So, but what the hell do you want to spray with GaN's lead, which is poison? And it's a gentleman behind, or if it's a man, maybe as a woman, or who knows, or maybe other sex, or we don't know. It's that kind of anarchy and such a free man promoter that he refuses to have a civil name. So it cannot be found by the tax office, cannot be found by anybody because he doesn't show his name.
But you know, in this world, they make a commercial, not for the quality. They make the money only.
I understand. I'm praying for their souls.
But sometimes they abuse a mark of Keshe Foundation. I know. This is the best way to take money.
So please learn it, do it, teach it.
Yeah, I say to you, I learn deeply, and I make something good with the quality, not with the electricity. I try to do this way, and I try to put the plasma fluid on my product. You see, Mr. Keshe say the first time, the first step we do the macra, and after we do with the capacitor, and after we do only with the gangs only. You see, we reduce the production with the car. This is the way that Mr. Keshe want to teach us. But to adapt to the new new plasma is very difficult. I know.
It's true. It's something we work on here every week, basically, is trying to phrase things and perceive things in a plasmatic way, rather than the way we've brought up to expect in the physicality sense.
It is nothing complicated. What it makes complicated is it is only our complicated mind.
Yeah.
And our habit. Let me open this. Our habit to look for the shape and not to look for what is inside.
Yeah. Right. This is the way of the world. This is the material.
You look at the shape outside and you don't look what is inside.
No,
that's the problem.
This is
can you see the mind? Can you see the intelligence? Can you see the wishes? Can you see the soul?
Yeah.
You see the shape?
Yeah, this is a
manifestations only.
Yeah, this is a material war. They see, what they say, they believe.
You see, you look at it. It's looks just it's a water, but it's a plasmatic water taken from the CO2 gas. So you have some gas at the bottom of the bottle.
Yeah.
You add clean water, you shake it, and you let it to settle down, and you use just the 1/3 from the top, and that's plasma water. And just a couple of days before, I had idea to spray that on my window. Unfortunately, I didn't clean the dust of the window, so that's why it left some small spots. Just I cannot focus my camera there. But what's the issue here? I had on the opposite building some big towers with antennas. Here already I had to put such a screening, such a shielding with a metallic wallpaper to stop those microwaves of boiling my brains. And I use a small radio frequency detector which shows the strength of the fields which come in. Oh my God, this is a lot. Let's reduce the sensitivity. Now it's the minimum.
Yeah.
You see, at the minimum sensitivity, it gives maximum detection.
Yeah.
So it should be a strong signal which comes from 100 meters. This detector is designed to find something in 1 meter distance, not at 100 meters. And now see something. If I put it behind the sprayed window, what happens?
Nothing.
It got shielded, and it's glass. It's no metal there. I just sprayed it with plasmatic water.
That's pretty amazing, Shandor. That's amazing. Did you sprayed it and just let it dry? You didn't wipe it off or anything then?
No, I just sprayed it, let it dry.
Huh. And you only sprayed the one window and left the other one, or how did that go?
I sprayed here and there, but mainly I sprayed this one. I sprayed it well. The other I sprayed it only on the upper part and not on the lower part.
Okay.
I was spraying actually with CO2 plasma water my plant to give it some feeding energy. And meanwhile, I had the idea, let's spray on the window as well. So now I have to clean the windows thoroughly, and when it's clean, then to spray it to remove the spots of dust.
Yeah, yeah.
You see, you have some dirt and some dust on it, or some small particles, and then you put water, then those will form such a dirty drops. So that's so beautiful.
So how could you spray it on the outside and make it stick so that water didn't wash it off? I know, but why not do both sides though?
Oh, because I have such a beautiful design, which it opens toward myself, and it's a huge wand. It's even difficult to clean it, so I need a long rod with a cleaner to be able to reach. It doesn't open horizontally; it opens vertically, and it's 30 kilograms heavy. It's a how much is that? 50 pounds weight?
Yeah, yeah.
Or 60 pounds weight or more, 65, 70 pounds. So a pensioner old lady is not able to keep her window open to clean it. It's a strong man. You need a muscle Arnold Schwarzenegger to hold it in one end and to clean it with the other. Otherwise it breaks by its own weight, or you need to put something under. But that's the fault of the design.
Okay, but if you could access, I'm just thinking, what if the spraying on inside knocks off half of the radiation, and spraying on the outside knocks off the other half? And I'm thinking, well, okay, that would be good.
In that way, possibly if you have several filters. But you see, this half-half doesn't always work in the terms of energy. You see, Inside we are 10 centigrades in the winter. Outside we are 5 centigrades. So I open the window to let the other 5 to come in and to make 15.
Yeah.
Not always works in that way, but it's something subject of experimenting.
Did you use CO2 and zinc oxide or just CO2?
It's a CO2, so-called CO2 made between a nano-coated copper plate and a nano-coated zinc plate in the traditional way.
Yes. Do you consider that zinc oxide?
Next time. Now I have to fix some plugs under the table. Next step. I have a broken wall outlet, not plug. I have to change the outlet with a new one and have some work with it to move these extensions cables, which are near myself, to a more proper place. So,
could you stick your hand outside the window and squirt your windows with it instead of holding it?
So those who are very technical and can afford, they can make a small drone with a sprayer.
An idea. The CO2 drone sprayer. Yeah, there you go. It can spray your outside of your windows so that you get that done. I was thinking, well, what could you mix with the CO2 GANs to make it stick to a window but not cause smearing and, you know, blotching and that kind of thing? Wondering how we can, like, and the other thing would be, how could you create a paint job maybe on a vehicle or a house that would you know, incorporate the CO2 GANs. I mean, obviously you could mix it in with a water-based paint, for example.
What about an atomizer?
Well, I might have stumbled on something because, like I said, when I was trying to rehydrate that Epsom salt GANs, it would not rehydrate. So it was made in a liquid form. So if it already has, it was made with the GANs in the liquid form and it dried to a crystal form. That's why I like it, because it has two properties. It can go from a liquid form to a crystal form. Just like water has two different properties. It can go from a liquid form to a frozen state form. So that was my observation of that for the crystallization of the when it goes from, you know, like when it goes from a salt state, which would the Epsom salt is, and it goes, I thought it would rehydrate back into that, but it stayed hard as a rock. I don't understand that part, because usually Epsom salt would get, once you get it wet again, it would get rehydrated.
Yeah, it usually dissolves fairly easily.
That's what I thought. It would just poof, go back into a liquid state, but and a lot of it did, but some portions of it said, no, I'm staying as hard as a rock and you can't bother me. And so I don't want to be a hog tonight. I'm sorry for hog, but I had a lot of stuff. But what you're looking at in front of you right here, I had a question for Sandor. Have you ever seen the different separations in your CH3? Like, you can actually see there's three, at least, well, I can see at least one, two, three, at least four, maybe five different separations in these containers. Or anybody that makes CH3, that has CH3 that won't settle down, I don't understand. It is actually taken a form itself, or the way it's sitting the way it's sitting.
Sorry. Can you repeat, please, the question? Because meanwhile, I got another question here in live regarding to go somewhere within 30 minutes. And I wasn't able to listen to both in the same time.
I was just throwing it out there because my CH3 is layered itself to a position where, you know, from top to bottom, I got 5 different layers, at least 4 different layers.
Ah, you have a higher variety of things inside. I don't know how you produced it. So if I may spotlight this one. So this is my CH3 GaNs. It's not yet washed. It's still in salt, and I see no layers. You see its aspect?
Yes, I have some like that.
And you see they are smaller, bigger, but it's more flocculated, more bigger chunks in it, you see?
Yes.
I think this is how CH3 should look, because before I did the same mistake like many.
Well, this
by using only iron, and I got something like this. And this, I think this is not CH3. This is just some rust. You see the difference?
Have you tried putting a magnet to any of those?
I have no very strong magnets, so that to attract you need a 20 kilograms force magnet. I have very tiny ones, just like for the refrigerator, or the strongest is from hard disk. But you see, this is only made with iron and no zinc, and that's not CH3. To get CH3, usually you need the zinc.
This is just pure CH3. This is iron on iron.
Yeah, look here. It has a different aspect.
Yeah, well, I nano-coat a piece of iron and then I put a non-nano piece of iron.
Yeah. There is also a little difference of color, so this is more towards orange. And this is more towards brown.
I can't understand why it doesn't settle down like it. Whatever.
This is that with iron and copper, no zinc. So you need zinc, presence of zinc, for instance, a galvanized piece of iron with zinc coated.
I don't mix the materials.
That's the way Mr. Keshe recommends, actually.
Yes, I know. I made a mistake by making. I know that I should have been making this with a nano-coated copper plate instead of just iron on iron.
No, you missed the whole point there, Mark, that Sandra was trying to tell you several times about the zinc. Zinc is the important one that Mr. Keshe has talked about before. Has to be in there to make the proper CH3 GaNs. That's what.
Zinc in the copper CH3?
What is CH3? Carbon and 3 hydrogens. So you need to create the conditions to attract carbon, which is between zinc and copper. And in the same time, you need a condition to attract the triple hydrogen, which is between iron, 56, and the nano copper, which is around 59. Difference is 3.
So the nano-coated copper provides that.
The nano-coated copper provides the fields with field strength of around 59. That it provides, nothing else.
And then the raw iron, what would that number be? The raw iron.
I think you can make a little drawing of this to clarify.
You were reading my mind. I was contemplating to open that.
Well done.
I was contemplating to do that.
Instant communication. It takes us longer to talk about it than to link our minds and do it.
So you see, here you have nano-coated copper. Now I put a symbolic thing for nano-coating. It doesn't look like that, you know very well. And you have something else here. So now when you have here copper, which is a nano-coated copper, copper has the mass number, if you look at the periodic table of elements, of average 64, but it's actually made of copper isotope 63 and 65. When you create a nanomaterial of it, then the atoms which are in a tight bond, in a molecular bond, they get some spacing in between. So you make them to release the energies, and it gets some distance in between, and it makes some interactions. In that case, the field strength, I'm talking about not a mass number, but a field strength, it is the mass number less than 5%. So you multiply that with 0.95, actually 0.94, 0.96, something there for copper. So this is how you achieve here a field strength of 59, which is this one reduced in nanostate. So now if you have a zinc, then that zinc has a field strength, but the field doesn't go so far. That is of 65 with zinc, but zinc also is made of isotope 60, 62, 64, 67, 68, 70, and so on. Maybe less than that, but maybe there are about 5 isotopes. And it's an average 65. So you have a spectrum of fields there, in fact. That's the advanced knowledge. And now you see what makes to manifest in salt water. It is the difference between these two. So this second plate acts as a filter. And you see the difference, let me put the Greek delta here, difference between 65 and 59, that's 6. And the carbon atom has 6 neutrons and 6 protons. You create a condition to attract, to absorb from here, from the air, from the environment, the fields of the carbon by attracting the 6 protons of it. So carbon gets into the water and it gets combined with the oxygen, which is a gas dissolved in water, and ultimately it's part of the water itself. And it gets combined, it's carbon and oxygen, so it gets CO2. And that is your gas which you observe there. So now, if you put here an iron which is galvanized with a thin layer of zinc, in that case you have a double filter, you have 2 conditions. And this is still the nano-copper. So between the copper and the zinc, you get a difference of 6, which is conditioned to attract carbon. And between copper and between the zinc, between the iron, which is here, you get a difference of 59 minus 56, which is the iron. This is 56, this is 65. Nano-copper is 59. So this is a difference of 3. So you attract fields of value of 3, which is equal to 3 hydrogens. So that you get the triple hydrogen. And these two get combined and you get the CH3. Of course, you don't get a pure CH3. If you put a metal inside, some ions of the metals get dissolved and you attract a wider spectrum, but mainly it will be CH3 if you do it properly, in condition of salt water.
May I ask a question?
Even 3. I still have 10 minutes.
The iron, because I never used iron with zinc on it. It was just pure iron. It was iron on iron. And I nano-coated, would a nano-coated, because I treated a piece of the same type of iron, just, you know, I cut it in half, and I put it in high caustic solution, heated caustic solution. So I thought that that was nano-coating the iron.
I understand. So if iron in a matter state has the field strength equal to its mass number, which is 56.
Yes.
And if you nano-coat the iron, you get a 56 multiplied with 0.95 or deducting 5%, you will get something of around 53. So now you change the condition. Nano copper is 59. Then nano iron is 53. The difference is 6 again.
6 again.
So you have a condition for carbon, you see?
Yes. Is that a good thing or a bad thing?
So, yes, it's okay.
Well, thank you. Because I thought I was in the same field parameters as if we were to have exactly what you wrote just prior to me asking the question.
So you have condition here for carbon.
A factor of 6.
Yes. Now, how you get the condition for hydrogen?
How do I get the hydrogen in that? Wouldn't that come? Don't we get hydrogen from the containers that we make it from?
It's pretty well staying there. It doesn't come too much out, except if you create a strong plasmatic condition.
Because I nano-coat the plastic containers to allow that to be my C bond, my carbon bond that comes through the container too. So, you know what I'm saying? So it will, a heated plastic is a carbon release or carbon.
Yeah, what conditions you need to release that from the plastic, and what will happen with plastic? You remember the old Coke bottle experiments?
Yes.
When Mr. Keshe put caustic liquid, the mysterious Keshe liquid, into the
yes, he used
bottles, and some bottles lost their necks. Well, the neck part, which was a different kind of plastic, it had a different crystalline structure, got the materials like hydrogen and carbon subtracted, but it lost the plastic. Did you lose the walls of your container? I don't think so.
Yes, I actually started to lose the walls of the container. This is my 4th.
Whoa.
Yes, it started it started to deteriorate to the point where it started to make stress cracks in the plastic.
Then you made there something very interesting.
And I have the containers, like I just said earlier, I had to change, I have to change my containers because there's too many cracks, because the last run I showed in the containers that the stress cracks were starting to get to the point where the salt and the GANs were sealing the cracks because they were leaking out of the cracks. So now it's to the point where I can't use them anymore. There's too many of them. I'm just afraid that too much will come out. So yes, I know that the condition of the containers has been moved to the point where they are, where energy can be moved through the plastic. I'm thoroughly convinced the process that I do is that all my containers have done the same thing. And the container that you've seen in the smoke that moved energy through the plastic, all that has to do is because all I did was change the condition of the plastic. Once you do that, then it's not the same plastic.
So you created a condition to attract out some stuff from the plastic, for instance, the carbon.
Yes. I think so. I'm just a painter. I'm not a scientist by any means. I'm just guessing at this.
You observe, and you try to figure out what happened.
Yes, exactly.
It's fine.
Thank you.
You're welcome. So we open new ways of knowledge.
I try to share as much as I can every day. I write as much down as I can. I take as many pictures as I can, and I will never ever not share everything that I do. Everything is for everybody. It's not mine. It's this is a gift from Mr. Keshe gave me this gift, and I can't give it back fast enough.
Thank you very much. Keep the good work on.
Thank you.
Now, next step will be to make GANs out of GANSes. Some people started the experiments.
My experiment's going to be plasma. I'm going to charge my GANs with pure plasma. You'll see it next week. I'm working on it really hard. I got a lot of things done. I'm ready. The preliminary stuff is done. It'll only take me another few days to get it done. So in my theory that makes sense to me that I'm going to try to make GANs with a pure plasma energy. That's my hope.
Nice birds in the background there.
Thank you, Mr. Sendor. I'm very happy to meet you.
Avec plaisir.
Oui, il n'y a pas de quoi. Je suis très, très heureux puisque j'ai rencontré quelqu'un qui m'a enseigné beaucoup.
No matter the words, the intentions go through from soul to soul.
No, because I speak in French. Excuse me.
I told that for the others.
Yeah.
The wish and the intentions behind the words go through from soul to soul.
Yeah, because I'm Buddhist. I know this way. I have a good feeling. I feel someone I need. I meet. I don't see you, but I have a feeling. You don't see me too. But the mind of the mind and the mind can touch each other.
Don't look at the container, look at what's inside.
No, Miss Keshe, work with your mind. Work with your mind is better. Work with your thinking.
You know, intention is senior to thought.
Yeah.
Even effort, physical activity is senior to thought, because the thought is the result of the contact with the physical reality, which makes perceptions, and the thought is nothing else but the evaluation of past and present perceptions.
Yeah.
And comparing it sometimes to your plans or your purposes or your wishes.
Last time I send you a picture. I say a soul. What Mr. Keshe say is composed by three parts. First is conscious, second one is unconscious, and the third one is karma. But Mr. Keshe haven't explained about karma. I'm waiting him. Because the karma is a principle thing. He control our conscious and unconscious. But if we know about karma, we know everything. Like we know a black matter, we know a matter and matter. Like this one.
Thank you very much for everybody for opportunity to be here, and thanks very much for Rick for doing this Keshe Plasma Reactor meeting week by week, year by year, and thank you for all who are participating to keep this alive. But now I have to leave. My wife is waiting in the door.
Yeah.
Thank you,
everybody. Bye everybody.
Thank you once again, Shandor. Appreciate your artwork on the board there and your great comments and explanations. Thanks so much.
It's my pleasure always.
Thank you, Shandor.
Okay, Mark, we're seeing some, these are...
oh, these are just filler pictures.
Epsom salt crystals, basically, is that right?
Yep, just, you know, sometimes we just like to look at stuff while everybody talks.
Absolutely, I appreciate it so much because we need to have some sort of video or picture up. Otherwise, the Zoom recording has a big blanco, and nobody likes to see a blanco.
So I got tons of pictures. I'm just sitting here listening. I just love just flip through them. So if it's background noise. But yeah, these are just the crystals from the Epsom salt and the potassium. Gluten. It's the human. It's the potassium you can buy at all the health food stores. And it makes nice GANs. It makes beautiful GANs. It was liquid, and it dries so nice. It just made so many different forms. It was pretty. And I like to take pictures, so don't anybody else got stuff, just please go right ahead, walk right in. I just like to look at it. I just love looking at our stuff, and it's fun to see. It's fun to play with. I got tons of stories, and then if we need to fill in time, but it's late. We've been going a long time.
Yeah, I was kind of thinking we might want to wrap things up here if we don't have any burning issues or inspirations to go on here. But sometimes that takes a bit of lull in order to bring it out, so I'm not pushing really hard, but it's up to what, 4 hours now, so it's probably adequate. I know I'm pretty tired myself, but still game, you know, somewhat.
Thank you so much, Rick.
Hey, and we all forgot to say a big happy birthday to you, my friend.
Thank you.
Happy birthday. Yep.
It was 5 days ago, but that's okay.
Close enough. I hope it was fun for you.
Well, somewhat.
Yeah.
It was nice to see all the greetings and whatnot, and yeah, it was somewhat fun other than the part where I got whacked out in gasoline working on a job and got sick for 3 days. But aside from that, it was good.
Didn't have your dad's spray bottle with you?
It's just I just got into a messy situation and couldn't get out of it, and got overwhelmed by gasoline once again, my arch enemy in life. But that just makes me stronger and more determined that the evil beast will be slain faster and easier than expected, which is, it's all good. Things are lining, the cosmos is lining up really interestingly right now, so yeah, it's time for big changes in the world and inside of ourselves at the same time. So
it's hard to say no to people that ask you for help.
Well, that's a big part of it, yeah. And I just sort of got myself obligated and have to earn a living too, so the two coincide in the wrong way sometimes. But I just get reminded that every time I have an altercation with exhaust fumes or gasoline fumes, I just it just reinforces in me the need to carry on with this work, to get the plasma teachings out there and get people more and more interested in working with it, and just hearing about it, so that we can transition away from our carbon-based thinking and carbon-based society into something much more compassionate, I would say. Once the full damage really gets known about what we've been doing to each other, literally, in the realm of vehicles and so on, well, we're going to be kind of embarrassed as humans, and we'll pass through that era quite rapidly, I think. You got a whole bunch of pictures here. We're going through massive amounts. This is Mark's speed pictures.
I'm trying to get to one picture that I want to leave everybody with. Where is it? It's and I want to leave it with a big smile. And next week I'm going to tell this story. And it's an incredible story, and it's a story that we can all enjoy, because it's a story that I've been telling about my mom and myself and the adventures of me and my mom.
Yeah.
There's my mom.
All right.
So, you know, this woman is 91 years old, and she's believed in everything that Mr. Keshe and we've been doing. And when we first started, believe it or not, this woman used to push this thing around, and she was going to the wheelchair. Now she uses this to hold the phone in her pop in order to get up to do the weeding. At 91.
Right on.
Backyard. Okay. Right now, I just could ask just a little quickie for all my friends here, just to say a little prayer, because this woman's in the hospital right now. She had a heart attack, and she survived a heart attack. And she's still with us, and she's there. And I believe it's because of everything and the knowledge that I've learned from the Keshe Foundation. I still have my mom with me.
Right on.
We'll talk about that next week.
Right on, Mark. Yep. That's great. You appreciate your mother so much. There's many people that have, broken families and so on. They just split up and don't even communicate, and here you are with this tight connection. That's wonderful.
She's the salt of the earth, and that's why the earth has to come out and sit out upon it again. And she's still with us, so I'm really happy, really happy. So she's with us. I told you she's going to come down and talk to us.
Oh yeah, that's right. You mentioned that. Well, that would be great if you could get her in for one of these sessions, or even a recording, if necessary.
Well, she's going to come down and sit in the stool live, and introduce her to all of us, all my friends.
I'd love to get her point of view and hear her perspective. That'd be so good.
Well, she's had enough things happen to her now where I've sprayed her, spritzed her, rubbed her, fixed her with the Gants and the pads and the healing pads, and this woman, what these doctors said to me is just, it floored me. I'm floored. I mean, like I said, this week has been amazing for me. It's unbelievable. And she can attest to it. She's 91. She has effort, and she has strength, and she believes, all my other part of my family thinks I'm a kook, but she believed in me, and look at her, she's, it's great.
It's still got a sparkle in the eye, yeah.
Rick?
Yes, hello.
Please, I'm a new one. Don't laugh after me. I have some question. Be crazy.
That's okay. Sure.
I really love. What I want to say correctly, I want to love, because this is very amazing to me. I have learning some other program. I am teaching about a herb for with the Chinese acupuncture.
Yeah.
Yes, you have something very like with Minecraft and the reactor, because the composition of the body of the man is made by the nature, and the character is the same thing. I see.
Well, you should put together a little presentation, perhaps, and teach us what you know.
No. I cannot teach that. I can give the picture and what I have drawn. It's like very look like they have a triangle and the middle, and they have inside coin and outside coin, but it's not the coin. Is a zinc and zen of the metal, because the body is composed by two parts: the physical part and the mental part, and not the mental but the energy part. Because physical part is matter, and the energy part is like what I can say, energy, like electricity, like power. Because we live with two kinds. We need a matter, and we need energy to let it move and live. It's very interesting.
Well, maybe we could get into it in more depth next week, perhaps. Spend an hour or so and do some drawings and make some comparisons and whatnot. Maybe that would be a good idea.
Yeah, I try to. Minecraft and it's same. I look it's something, because our body is made by the nature. You see. It's very. I want to present this for the health, because It's very difficult. You know, medicine, Chinese medicine, they have only 5 elements. And now we know the 5 element is not equal, because 5 elements we have 2 and 3. It cannot balance. You see, it can balance if we have 6 elements. Now we find the 6 elements, and they divide in 2 parts. One part for the matter and one part for the energy, and they balance itself. It's very nice. It's a new way of the Chinese medicine. You know, I know nothing about medicine, but I come inside. I try to make a number on this, numbering the point of acupuncture, and I play with this, and I make it like a matrix. And with the matrix, I make in the 2 triangle, and make in the hexagonal picture. It's very nice.
Okay, well, can you do that next week for us?
Yes, I try to do.
All right, great, thank you.
Okay, bye bye.
All right.
Hello Cúc.
Bye bye.
Đó, thì Cúc nghe tiếng nói chuyện với người ta không?
All right, I think we're going to wrap it up for this week, unless there's any protest otherwise. Let me put my video on. Oops, I can't. I have to... Oh, yeah. I just have to interrupt your screen sharing there. Mark. There we go. And... oh, that didn't work either. Let's try again. Select something and stop the screen share. Back to this. Spotlight, cancel, back down to second screen, and spotlight. Oh yeah, and enlarge. Multi-procedure there. Okay. Well, interesting night. Lots of comments and interesting things to look at, think about. And we can look forward to a little presentation for next week as well. Okay, I think we'll wrap it up for today, everybody. It's been fun as usual. And this is Keshe Plasma Reactor Group for what's now Wednesday, June 7th, 2017. And as always, thank you everybody for attending. And that's it for today.
Thank you so much, Rick.
Thank
Cheers.
you, Rick.
Happy
Cheers.
birthday.
Thank you, Rick. Thank you, everybody.
Alright, we'll end the live stream for now. Until next time.